morning students. Welcome you all on YourPedia panel. So my dear students, as you know, YourPedia is the largest platform for interview guidance. And you already know that on YourPedia panel, marathons or I can say the interview series related to civil, mechanical, CSE, electronics, electrical, all the good marathons which are basically dedicated for the interview questions, that is already uploaded. You can go and watch those interview playlist or interview marathon. So continuation to that part, this side Mukesh sir from YourPedia, I am going to start a marathon series that is specifically for interview type problems. What type of problems they may ask, question related to data structure, algorithm, programming point of view, which you may face in each and every interview related to PSUs like IOCL, DRDO, Airport Authority, Food Corporation of India, or interview related to your higher studies, or interview related to your state level, any of the exams if you are from the computer science background. So my dear students, this marathon is almost, I can say, like in this marathon I am trying to cover the most important problems related to data structure, algorithm, or programming. Now start with the first algorithm. As you know, if you, even though you may say or not like say that your favorite subject is algorithm, data structure, or the programming, but by default, but as you are from the computer science background, everyone expect that yes, you know the core, or you have the core or the basics idea related to the algorithm, data structure, and one of the programming language. That's why my dear students, this subject is, or I can say this marathon is very important when if you are going for an interview. So my dear students, in this series or in this marathon, I am trying to cover the, or I can give you the maximum number of problems which are frequently asked problem of algorithm, data structure, and programming. So my dear students, this marathon is very important for you. So please watch till the last, because in this again I am covering all the major concepts. I'll try to explain even their working, how they work, what are the different time complexities, what are the main differences between all the data structures, how you can declare something. Fine, my dear students. So let's start from our first question. In right now, first I just try to cover the important, as you know, if I talk about the algorithm, so searching and sorting are the most important concept which you may face. Fine, my dear students. That's why first I just try to cover searching and sorting with their time complexity, and also I am trying to cover their working. Keep in mind, sometimes even whenever they approach with the one problem, they may ask, they just start from the basics problem, and in depth they may ask the problem related to their working. So let's start with the first problem. The first problem is, what is the best case time complexity of insertion algorithm? If I talk about different sorting technique, here the question related to insertion sort, but we know that the major or the most important sorting techniques are insertion sort, merge sort, quick sort, heap sort, bubble sort, selection sort. So first, the problem first is related to the insertion sort, and he want to know the best case time complexity. So if I talk about the insertion sort, what the basic idea or what are the basic concept behind the insertion sort, or how insertion sort works, that is very important. If you know the working of insertion sort, I think you can easily give the answer of insertion sort. See, my dear students, how insertion sort works. If I talk about the working of insertion sort, then first one element came as my array haven't any previously any element, so it just store into the array. Whenever the next element came, we just compare with the previous element, try to find out the comparison. If comparison false, then we just swap. So in this way, until unless we are not finding the exact location of that particular element, until unless we are performing the comparison, we are performing the swap. So in this way, my dear students, the best case performance of insertion sort is order of n. When it is order of n, when input are in sorted order, because whenever input came and input are in sorted order, then there is no need to perform these swap operations. Whenever a new element came, you need to compare with the previous element, or I can say the last element of the array, and as the given or the new or the current element is the bigger one from the last element which we already inserted, so there is no need to perform these swap operations. Here I am taking one assumption that you have to sort the array in ascending order, and the input are again came in the ascending order. That's why in this case no need to perform any swap operations. That's why the worst case time complexity of insertion sort is order of n, and when the input is already sorted. So in this way, you have, first of all, my suggestion to you is go with the all the working of each and every sorting and searching algorithm. Once you know the algorithm working, then I think these are the very simple problems, and whenever someone asks you the problem related to these, you can easily identify their solutions. So how you can give the answer? Sir, the best case time complexity of insertion sort is order of n, and the case is when input is in sorted order. If they ask you please explain how it is order of n, then you just take an example, or just by without taking an example, you may say that sir, as the input is sorted, in that case we just need to perform one comparison for each and every element, but there is no need to perform any swap because the input is sorted order. That's why the best case time complexity is, even though I am writing here the notation big O, so you may say that sir, how you can say the best case time complexity is big O of n, it should be omega of n, because I am saying which complexity I want best case. Because I already denote you that I want best case, that's why in that case you may write anything. So it is order of n. Fine, my dear students. So keep in mind, best case time complexity of insertion sort is order of n. Now the next problem is, what is the worst case time complexity of insertion sort? We know that in the best case it is order of n, but what is the worst case time complexity of insertion sort? So my dear students, if I talk about the worst case, suppose that I want to sort an array in ascending order and input came in descending order, or you can take the vice versa scenario. Fine. So now my dear students, for the first element no comparison, no swap, but for the second element we have to compare with the last inserted element, because the given input, the current input is smaller than the last element which we already inserted. That's why we have to perform swap. So I can say for the second element I have to perform one comparison and one swap. In the similar manner, my third element, for third element I have to perform two comparisons and two swap. In the similar manner, for the fourth element I have to perform three comparisons and three swap. In this way, if I talk about total number of comparisons required, that is again order of n square, and if I talk about total number of swap operations required, that is again order of n square. So my dear students, asymptotically n square plus n square is 2n square, that is order of n square. So the case is when I want to sort in ascending order and input came in descending order. In that case, insertion sort gives me the worst case behavior, which is big O of n square. So here the worst case time complexity of insertion sort is order of n square when the input is in reverse order. That means if input is in ascending, I want to sort in descending, or input is in descending, I want to sort in ascending. So my dear students, keep in mind the best case big O of n, or even the best answer is, you can say the best case is omega of n, and the worst case is big O of n square in the case of insertion sort. Now I'll explain you by taking an example the working of insertion sort. So here is the working of insertion sort. See my dear students, my problem statement is, suppose the first I want to discuss the best case behavior, and as I told you that the best case time complexity is omega of n. Fine. So I want to prove you that why the best case behavior of insertion sort is omega of n. Listen carefully my dear students. Suppose I have an array and the array, the input came in ascending order, in the sorted order, that is 10, that is 20, that is 30, and the next one is 40. Suppose this is my first element, second element, third element, and fourth element, and I want to sort this given array into ascending order, as the input came in ascending order, and I want to sort this in array into ascending order. So my dear student, suppose that this is my array. So first element came. So because previously no element is inserted, so it inserted as it is, and in that case please tell me the number of comparisons and the number of swap. So till now I cannot perform any comparison and I cannot perform any swap. That's why 0 comparison, 0 swap for first element. Now suppose my dear students, I just want to insert 20. So what I have to do? I have to compare 20 with 10. As 20 is greater than 10 and my task is to sort this array into ascending order, that means the newly element is greater than the previously inserted element. So just one comparison is sufficient, no need to perform any swap operations. It means for the second element I just perform one comparison, but I just no requirement of any swap. Moving towards the third case, suppose when the 30 element came, again I just compare it with the last previously inserted element, as 30 is greater than 20, so I just insert, no need to perform any swap operation here. So again for the third element, one comparison, 0 swap. In the similar manner, if I go with the fourth element, just compare 30 with 40, as 40 is greater than 30, I need to insert 40 here. Again for this element also one comparison and 0 swap. So in this way my dear students, if I want to sort in ascending order, input came in ascending order, or if I want to sort in descending order and input came in descending order, in that case total number of comparison required is n minus 1. Here number of elements are 4, I required total 3 comparison to sort, but I required 0 swap operations. So n minus 1 plus 0 is n minus 1, which is asymptotically n. So in this way I can say the best case behavior of insertion sort is omega of n. So in this way you have to know how to deliver this answer whenever someone asks you related to the time complexity of best case as well as the working of insertion sort in best case. Moving towards the next concept of, that is the worst case. So I already mentioned you that worst case is big of n square. See my dear students, suppose n square came when input and the objective is somewhat different. It means suppose input is in ascending order, or I can say descending order, suppose 50, 40, 30 and 20, but I want to sort this given input into ascending order, means final objective is my 20, 30, 40 and 50. So in this case my dear students, listen carefully. Again the same approach, number of comparison, number of swap. Now tell me, as the first element came, for first element no need to perform any comparison, no need to perform any swap. That means 0 comparison, 0 swap. Moving towards the second element, that is 40. When 40 compare with the 50 and my task is to sort this array into ascending order, so I need to perform a swap. First I need to perform a comparison, then I need to perform a swap. So the resultant output look like this, that is 40 and 50. So here for the element 40 I perform one comparison as well as I just perform one swap. So one comparison, one swap. Now suppose next element came is 30. So first 30 compare with the 50, as 30 is smaller than 50, so we just perform one swap, that is 40 is here, just perform the swap with 30 and 50. Now again, because this is not the correct position of element 30, again I have to do the comparison, and if required then go with the swap. Then again 30 and 40 we have to perform a comparison, as 30 is less than 40, so do a swap operation. So 30, 40 and 50. It means first I do a comparison with 50 and swap, then I do a comparison with 40 and swap. It means for the element this one I just perform two comparison, two swap. In the similar way for 20 I have to perform three comparison, three swap. For the nth element I have to perform n minus 1 comparison, n minus 1 swap. Why? Because for the second element one comparison, one swap. For the third element two comparison, two swap. For the fourth element three comparison, three swap. For the nth element n minus 1 comparison, n minus 1 swap. So if I want to find out total number of comparisons, that is asymptotically n square, but not the exact n square. In the similar way, if I talk about the total number of swap, those are again n square. So n square plus n square is big O of n square. So in this way my dear students, you can say that the worst case time complexity is n square, best case time complexity is n in the case of insertion sort, and the criteria is the best case behavior when I want to sort in ascending order and the input is also in ascending order, and for the worst case reverse is the order. Fine my dear students. So that is all about insertion sort. Now after insertion sort, the next problem is what is the best case time complexity of quick sort. So my dear students, as you know, the quick sort is very important. You have to know the time complexity in best case as well as the worst case, and the important part here is in the quick sort you have to know the working of quick sort. As you know, quick sort, first of all it is divide and conquer technique. And the second point is it internally uses an algorithm who actually perform the sorting task, and the name of that algorithm is partition algorithm. So one my suggestion to all of you is, my dear students, whenever if you want to learn the quick sort, heap sort, merge sort, so please follow, or merge sort, quick sort, heap sort, please follow our the standard, the bible of computer science, I can say, algorithm book, that is Introduction to Algorithm by Coleman. So my dear students, please refer that book for sorting, searching, data structure part and all this stuff. So now, as I say that the main task in quicksort is done by an algorithm that is called the partition algorithm. Now my dear students, listen carefully about the partition algorithm. What the partition algorithm is and what is the main objective or the main working of partition algorithm. See my dear students, if I talk about the partition algorithm, what it does, it just select one element, and now the task of that partition algorithm is to move that selected element, which we can call it as a pivot, move pivot element to its correct position in the array. And the meaning of correct position is, suppose I have an array of n size input, that is random input, that is not a sorted input. In that case, suppose I just pick the last element. Now we know that the particular last element may be the first smallest element, maybe the second smallest element, maybe the third smallest element of our input, or maybe 25th, maybe 50th, maybe 75th, maybe 62th, whatever it may be, at least it is some index while we go with the sorting, fine. Or after the sorting, that particular element is have some exit sorted element, or exit smallest element, I can say. So my dear students, the task of partition algorithm, listen carefully, is select one element, that is called the pivot element, and after when we just completed one time the partition algorithm, when we execute one time the partition algorithm, it just move that pivot element to its correct position. Suppose that my input is 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. I have an array of 100 element, but they are random in nature, means input may be 20, 10, 100, 70, 60, it may be anything. And suppose that the last element is the element 50, that is 50. So after performing the partition algorithm, the element 50 move to the fifth location. It means 50, because if I sort this input, then 50 is at fifth position. If I start the first element as the first position, then 50 must be at the fifth position. That means the partition algorithm, or I can say the fifth position is the correct position in sorted order of element 50. So that is the task of partition algorithm. That is, it select the pivot element, move the pivot element to its correct position. That is the main task of partition algorithm, and it also do one more task internally, and that I can say even by default automatically is done while performing the partition algorithm. That is, it just move the pivot element to its correct position, and listen carefully, and all the elements which are shorter than this pivot element are to the left hand side of pivot element or the fifth position. All the elements which are greater than this 50 are moved to the right subarray. So in this way, I generally says the partition algorithm perform three main tasks, that is selecting the pivot, moving the pivot into its correct position, and all the element which are smaller than the pivot element move to the left subarray, all the element which are greater than to the pivot element are moved to the right side subarray. Now the left subarray or the right subarray may or may not be sorted. So what I have to do, again I have to perform the partition algorithm on the left hand side, selecting pivot, moving pivot to its correct position. Again I have to perform the partition algorithm on the right hand side part. And my dear students, listen carefully. Sir, what is the time complexity to perform or to apply the partition algorithm one time? Listen carefully, my dear students. If I have an array of size input n, and if I want to perform the partition algorithm one time, it guaranteed that at least one element move to its correct position. The correct position means when input is in sorted order. But keep in mind, partition algorithm take order of n time complexity because it has to perform some comparison and some swap. That's why, my dear students, asymptotically each and every time the time complexity in best case, worst case, or whatever the case it may be, it will take theta of n time. Keep in mind, each and every case partition algorithm take theta of n time. Fine, my dear students. So that is the one problem, what is the working of quicksort, and the actual working is done by, or I can say the actual sorting is done by the algorithm called partition algorithm, whose time complexity in all the cases is theta of n. Fine, my dear students. So now moving towards the problem, that is what is the best case time complexity of quicksort. So the best case time complexity of quicksort is n log n. The best case time complexity of quicksort is n log n. Listen carefully, my dear students. N log n. How it is n log n, I'll just explain. The next problem is, what is the worst case time complexity of quicksort is n square. Keep in mind, it is n square, but best case is n log n. Now I have to explain you why it is n log n and why it is n square. So my dear students, if I go with the next part, that is quicksort best case. So my dear students, this is my input. Listen carefully, this is my random input. What I have done, I just select the last element as the pivot element, because the task is done by partition algorithm. Now suppose that in the best case, I am talking about the best case, and best case time complexity is n log n. So how it is n log n, I'll explain you now. So partition algorithm select the pivot element, and suppose that after completion of the partition algorithm, this pivot element moves at the middle. So I say that all the element which are less than this pivot element P1, this is my P1, all the element which are less than P1 are on the left subarray, or the element which are greater than P1 are on the right subarray. It means, given input, I divide the array into two subarray, that is subarray 1, subarray 2, and one element is already sorted. Yes or no, my dear students? Again in the similar manner, now my task is to, and it will take n time, because I just perform the partition algorithm. Now I have to perform the same partition algorithm on this left side subarray and on this right side subarray. But my task is, because we know that the number of element in this subarray is now n by 2, not n, or again here n by 2. you can just subtract one element because one is already sorted, maybe from this side or maybe from this side. So in this way again it will take n time, where n is my now n by 2. Here again n is my n by 2. This is the time of partition algorithm next iteration. For that's why initially I have n element. I divide the array into two subpart, each of size n by 2, and for performing this task I will take n time, and this n time is partition algorithm time. And if you just solve this recurrence relation, it give you n log n time complexity. You have to know how to solve these recurrence relations. Fine, my dear students. So that is the case when quicksort gives me the best case, when it divides the array into two sub-arrays. It doesn't mean that it always provide me the exact number of element on both the sub-arrays. It may be somewhat different, but still the base is changed, but the final asymptotic time complexity is n log n only. Fine, my dear students. So in this way the best case time complexity of quicksort is n log n. Now talking about the worst case behavior of quicksort, the same case as I already told you, the worst case time complexity is n square. Why? Listen carefully, my dear students. Again I just considered the n random array and my task is to sort this array. Now listen carefully, my dear students. Again I have to perform the partition algorithm. It just select this element as the pivot element. But suppose my element is like this: 10, 20, 30, 40 or 50, or you can consider in descending order. So now in this case this is my pivot element. So after performing the partition algorithm, can anybody tell me what is the location of element 50? As this is the correct position of element 50, so 50 still be here, and all the element which are less than 50 move to the left subpart, and all the element which are greater than 50 move to the right subpart. But we know that there is no element greater than 50, so the size of right subarray is 0. 0 number of element in right subarray, but in the case of left subarray I have n minus 1 element remaining. So again my task is to perform, and it will take how much time? N time it already take, that is the time of partition algorithm. So my dear students, again I have to perform the partition algorithm here. Now 40 is my pivot element, 40 still move to here, right hand side, no subarray, then 50, then empty subarray, and here I have 10, 20 and 30. So again I have to perform partition algorithm here, but this time it will take n minus 1 number of element. Yes or no? So time complexity is order of n. Again I can say asymptotically. Fine. So in each and every case the time complexity is order of n of the partition algorithm, and this such partition algorithm, how many times I have to apply this partition algorithm is, I can say n time or n minus 1 times. Fine, my dear students. So talking about the recurrence, initially I have n element. I apply the partition algorithm which will take n time, and it divide the array into only one half, because one half haven't any element, but the one half has n minus 1 element. So if I just solve this recurrence relation, it gives me order of n square time complexity. You can consider one more example or one more input. Suppose that right now the input is 10, 20, 30, 40 and 50, that is in sorted order, but suppose that my elements are 10, 10, 10, 10, 10. So again if you just apply the partition algorithm, it select this, suppose it select this element as the pivot element. So it perform the partition, selecting the pivot, storing the 10 into its own position, all the element which are less than equal to that are be here. Fine. Again 10, all the elements are should be here. Yes or no? In this way again I have to perform n minus 1 or n time, each time take n, which is again going to be n square, my dear students. So that is all about quick sort. So my the answer for the problem is, the best case is n log n, recurrence is T of n equal to 2Tn by 2 plus n. What is T of n? T of n represents the time complexity to sort n element using quick sort is 2Tn by 2 plus n, that is n log n. In the worst case, T of n is equal to T of n minus 1 plus n, which gives me order of n square. So in the case of best case, n log n in quick sort. In the worst case, n square. When the n square is when input is sorted or all the elements are, all I can say almost all the elements are same. In these two scenarios, quick sort gives me worst case performance. So always keep in mind, my dear students, we already cover 4 major problems. Best case insertion sort, that is n, worst case n square, best case quick sort n log n, worst case quick sort n square. So keep in mind these are the most important problems, and I already discussed the working with you. Now the next problem statement is, what is the best case time complexity of bubble sort algorithm, that is order of n when input is already sorted. Next is, what is the worst case time complexity of bubble sort algorithm in worst case, that is n square. So my dear students, we already discussed two type of sorting, one is insertion, one is quick sort. Moving towards the bubble sort, as the name suggests, bubble. Bubbles means it just jump one after another and find out the exact location of element. Suppose that, my dear students, the input is in ascending order 10, 20, 30, 40 and 50. Just consider this array. Now my dear students, I just start my comparison with 10 and 20. Which one is smaller? 10, and no need to perform any swap because my input is 10, 20, 30, 40 and 50. Now compare shifting the elements and I can say shifting the indexes and start next, compare next two element. Next two element are 20 and 30. Is 20 is less than 30? Yes. So again shifting your comparison, now you have to perform a comparison between 30 and 40. Again no swap, 30 is less than 40. Next you have to perform the comparison between 40 and 50. Again you get to know that 40 is less than 50. That's why no need to perform any swap, and that is your termination condition. If you just not perform any swap, then it will take order of n time. But in the similar manner, I can say if input is in descending order and you want to sort the input is in ascending order. Like if the I can say the input is 50, 40, 30, 20 and 10, and your requirement is 10, 20, 30, 40 and 50. So what you have to do? You have to perform a comparison between first two element, those are 50 and 40. So you just compare 50 and 40, as 40 is less than 50, so you need to swap. So now my input scenario is 40, 50, but remaining elements. Again in the similar way you have to perform the next two comparison, next two, so it will take n square time complexity. So finally I can say in the best case it will take order of n time, or best, the better answer is omega of n time, and in the worst case it is n square. Moving towards the explanation or the working of quick sort. Next is bubble sort. Bubble sort best case. So what the bubble sort best case is? See my dear students, this is my input 10, 20, 30 and 40. You just perform the comparison between 10 and 20, because you just perform one comparison, 10 and 20, 10 is less than 20, no need to perform any swap operations. So what you have to do next, just compare 20 and 30. Again 20 is less than 30, no need to perform any swap. Next you have to compare between 30 and 40. Again 40 is less, 30 is less than 40, no need to perform any comparison. So you just perform one comparison here, one comparison here, one comparison here, or I can say n minus 1 comparison you just perform, but 0 swap we have to perform. That's why the time complexity is, or better I can say, omega of n. Fine. So first you just take two element, perform the comparison, next two element perform the comparison, next two element perform the comparison. But if I talk about the worst case, see my dear students, now listen carefully. Suppose my input is 40, 30, 20 and 10. Now you have to perform the comparison between 40 and 30, as 30 is less than 40, so 30, 40 you just perform swap, then 20 and then 10. Next you have to perform the comparison between these two, yes or no. So input is 30, 20, 40 and 10. Next you have to perform the comparison between these two, that is 30, 20, 10 and 40. Now the biggest element, or I can say the largest element, move to its correct position. Now again for the next pass you have to perform again these two comparison, again these two, next pass again these two. Fine. In this way my dear students, it's give you n square time complexity, because in each and every pass n minus 1 comparison, n minus 1 swap. In this way we have to perform, I can say, almost asymptotically n passes, each pass take n time, that's why n square time complexity. So my dear students, if I want to conclude till now, so insertion sort, quick sort and bubble sort, I just want to give you best case, worst case. Best case is n, best case is n log n in the case of quick sort, and best case is n here. But in the case of worst case in insertion sort is n square, n square and n square. So keep in mind all this stuff with their working. So till now we just cover only the basics, the 6 questions, but within these 6 questions we already cover their working, their best and worst case behavior, my dear students. Moving towards the next problem. So the next problem, my dear students, is the next sorting algorithm. What is the best case time complexity of merge sort? In the similar way, what is the worst case time complexity of merge sort? So the first problem is the best case time complexity of merge sort. So my dear students, it is n log n, and if I talk about the worst case, it is again n log n. So I can say the best and the worst case behavior of merge sort is again n log n. So my dear students, if someone asks you what is merge sort, so your answer should be like, sir, it is a divide and conquer technique whose time complexity is n log n. We have two main major point also, which we are going to discuss after completing all the sorting algorithm, that is a given sorting technique is in place, is a given sorting technique is stable. So for all the techniques, all the sorting techniques, we have to explain about in place and stable. So right now we are not bothered about that, just go with the main concept of working. So how the merge sort behave? What is the working of merge sort? So the simple answer is, sir, it is divide and conquer technique whose time complexity is theta of n log n. If I talk about the working of merge sort, my dear students, see, in the quick sort, the main task of sorting is done by partition algorithm. In the similar way, the main task of sorting is done by a procedure, or I can say an algorithm. You can call it as a merge procedure. Merge procedure. Again, my dear students, listen carefully. Partition algorithm take theta of n time. In the similar way, merge procedure take theta of n time, whose task is to sort. What is the task of merge procedure? Listen carefully, my dear student. This point you have to listen carefully. The task of partition algorithm is to select the pivot element, move the pivot element into its correct position, and divide the arrays into two subarrays. In the similar way, my dear students, the task of I can say the merge procedure is to sort two sorted subarray. My dear students, listen carefully. The task of merge procedure, I am not talking about merge sort. The task of merge procedure is to sort two sorted subarray into a new array. Keep in mind, to sort two subarray which are sorted, and now I have to sort these two sorted subarray into a new array. That is the task of merge procedure. Fine, my dear students. So the complexity is n log n in each and every case. Now I will explain you the working. Moving towards the working, see, my dear students, first of all I want to tell you the working of merge procedure. The working of merge procedure, and the working of merge procedure is theta of n. Then the time complexity of merge procedure is theta of n. And what is the task of this merge procedure? Suppose that I say to sort two sorted subarray. I have one sorted array A, I have one sorted array B, here 10, 20 and 30, and this is 11, 21 and 31. So what it has to do is just take pointers, perform the comparison between 10 and 11. So it has to sort these two sorted subarray into a new array. So just take 10 and 11. Which one is smaller? 10. So just increment the pointer. Next, perform the comparison between 20 and 11. Who will be here? 11. Just increment their pointer. Next, 30 and 21. No, 20 and 21. So 20 is here. Just increment the pointer. Next, 30 and 21. Who is there? 21 here. Next, increment the pointer. Next comparison is between 30 and 31. Who is here? 30. Next, increment the pointer. Now pointer is out of the boundary of array. That's why, because this input is sorted, just copy paste. So how many comparison? 1, 2, 3, 4, 5, and now copy pasting again n or n. So total element has n and n, m you can say. So total number of comparison is m plus n minus 1. If m and n are equal, so n plus n minus 1, which is 2n minus 1, which is theta of n. Keep in mind. Fine, my dear students, this is n, or I can say big O of n. That's why I can say merge procedure take order of n time, and it just sort two sorted subarray into a new array. Fine, my dear students. So in this case, if I talk about now the working of merge sort, previously I just discussed merge procedure. Now working of merge sort, and I tell you it will take n log n time. Fine. How? See, my dear students, it first divide the array into two half. First it divide the array, next it divide this array into two half and this array into two half. Next it divides this array into two half, this array into two half, this subarray into two half, this subarray into two half. In this way, suppose this one, this one, this one, this one. Suppose we have 8 elements. So in this way, finally it just takes the size of subarray is small. Now it, because the number of element is less, I can say 1, here again 1, and if array has only one element, they are already sorted in nature. Now I just combine with the help of merge procedure. I just combine. So after combining these two array, this is my new sorted 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 array. Again apply the merge procedure on these two sorted subarrays, one sorted subarray, again apply for these one sorted subarray, again apply for these one sorted subarray. Are you getting my point, my dear students? In this way, this is the task of merge procedure, this is the task of dividing the arrays. That's why it is called divide and conquer technique. So again, if I talk about the recurrence, suppose I have n element, because it is dividing the array into always almost equal half. So we divide the array into two parts. Every time two part, size is, each subarray size is n by 2, and now I have to perform the sorting, which will take order of n time using merge procedure. So if you solve this, it will give you n log n time complexity. So my dear students, in the best case, in the worst case, merge procedure always take n time. That's why, and we divide the array into two halves. That's why the time complexity of merge sort in best case as well as in worst case is n log n. Fine, my dear students. So moving towards the conclusion part, if I talk about here merge sort, so best case is n log n and the worst case is again n log n. Fine, my dear students. So we already cover the 4 important sorting technique with their time complexity, with their recurrence relation, with their best case and worst case behavior, with their working. Now the next problem is, we completed what is the worst case, best case of merge sort. Now moving towards the selection sort. What is the best case time complexity of selection algorithm? That is n square, keep in mind. And what is the worst case? It is again n square. So in both the cases of selection sort, it will take n square time complexity. Now if I talk about the again the working principle of selection sort, how it works, see my dear students, its task is like it just start the iteration, and its task is, and one important thing about the selection sort I want to say, in each and every pass at most one swap operation it will perform. It means if my problem statement is I just bother about the swap operations, tell me which is the best algorithm or which is the best sorting algorithm, your answer will be always selection sort, because in each and every pass it gives me the minimum number of swap, that is at most 1. Listen carefully, my dear students, this point. Fine. Now moving towards the working of selection sort, what it does is, fine. See, if I talk about selection sort, it gives me order of n square in both the cases. Fine. See, my dear students, suppose my input is 10, 20, 30 and 40. What it does is, in the first pass, its task is to just compare and swap the first element with the minimum element. So this is my first element. I have to compare this element with the minimum element. So for minimum element, suppose that till now 10 is minimum, then I perform 10 and 20, still 10 is minimum, then perform comparison between 10 and 30, still 10 is minimum, then perform 10 and 40, still 10 is minimum. Afterwards I just perform a swap because one pass is completed. So my input is 10, 20, 30 and 40. This is my first minimum, but it already take n time because n time for comparison, constant time for swap, that is n plus C is n. Now I have to perform the second minimum. So this is my second minimum. Again I have to compare, maybe here is my 5 or here is my 15. So 15 and 10, 20, the next minimum is my 15, not the 20. But in this case, because the input is sorted, that's why. Then I have to perform again, still it will take n time. So in this case, my dear students, n square is the time complexity, because each pass take n time, total n passes, it will take n square time complexity. Suppose maybe you are bothered about, sir, tell me about the descending order, that is 50, 40, 30 and 20. So first what I just considered that my minimum is only 50. Fine. Now 50 and 40 minimum is 40, 40 and 30 minimum is 30, 30 and 20 minimum is 20. So I just perform a swap operation between 20 and 50. So the input is 10, 40, 30 and 50. Fine, my dear students. So this is my first minimum. So I can say finally in selection sort, after one pass, the first minimum it move at its first place. So for that I just take n time. So in this way I have to take n passes. So n into n is n square time complexity. So the selection sort time complexity in best case, in worst case is n square, but it is good when we are bothered about or we are having a concern related to swap operations. So I want to write here, yes, selection sort, it is best case n square, worst case n square. Fine, my dear students. So these are some of the important sorting technique. Next we move on heap sort. So again, what is the best case time complexity of heap sort? N log n. What is the worst case types is n log n. So my dear students, now I want to explain you about the heap, the complete heap, where first we just discuss what the heap is, types of heap, and then I can say we have different operations like insertion, deletion, heapify. Then we have one approach that is called build heap. If I want to create a heap, it will take order of n time. Generally it will take n log n time, but with the help or with the method of build heap, I just take order of n time, and after constructing the heap I have to like give you what I can say, how I can sort a heap. So it will take n log n time. So my dear students, heap, what the heap is? So heap, again it is very important, and again whenever you go with any interview, my simple suggestion is, my dear students, whenever you just go with the data structure and algorithm part, you have to know the applications of each and every data structure. First thing, you have to know when to use 1D array, 2D array, linked list, stack, queue, tree, graph, hashing, concept of hashing, what are the applications, real time applications, what are the advantage of one over the another, when to use which data structure. In the similar way, about the searching and sorting technique, you have to know the recurrence relation, you have to know the best case, worst case time complexity, you have to know which is stable or unstable, you have to know which is in place, not in place, and when to use which sorting algorithm. So these are the most important topic. And next I just want to add working, and with working, in the rarest of the rare case, they ask you to write the pseudo code, or I can say the algorithm of any problem. But my dear students, still you have to follow the core main book, and you can also use the Google resources where you can find out their abstract algorithm, how to write the algorithm. I think like out of 1000 interviews, only 1 or 2 interview may ask to write a program, but most of them just go with their algorithm only. So these are some of the questions I already talked about. About the data structure part, the important one is limitations, advantage and disadvantage, and then their applications in the similar way, sorting and searching algorithm in place over stable. Now I want to explain you the heap sort, the working of heap sort. So first of all, if I talk about heap, what a heap is, so we can say it is a almost complete binary tree. Keep in mind, it's a almost complete binary tree. If someone asks you what is binary tree, then the answer is binary tree is a tree in which each node has, in a tree, each node has at most two child. So I can say at most two child. Each node has at most two child. And what do you mean by almost complete binary tree? It is again a binary tree in which except the last level each node has at most two child. Fine, my dear students, that is all a heap. Talking about the type of heap, so we have mainly two type of heap. One is min heap and the next is max heap. Fine. So if I tell you what is min heap, so your answer will be, sir, it is a heap having some property, that is the root element, or I can say the parent node is always less than equal to its left child, less than equal to its right child. Fine. Or I can say less than equal to right child and left child. Fine. So now talking about max heap, again parent node is greater than equal to right child, greater than equal to left child. So that is the basics of heap. So I can say min heap is parent node is less than to left child or less than equal to left and right child. In max heap, parent node is greater than equal to its right as well as to the left child. Now if I want to insert any element in a heap, suppose that I just talk about here the min heap, that is 10, 20, 30, 40, 50, 60 and 70. As we know that this is a min heap, that means min heap means this node is less than equal to its left right child, this node is less than equal to left right child, this node is less than equal to its left and right child. So if I talk about the insertion, so if I want to just insert an element, suppose that is 80, so as you know we have to insert at the leaf node at the last level, last position. So if I just insert 80 here, after inserting I have to perform a comparison between their parent. So as we know parent is smaller than the newly inserted element, so there is no requirement of any swap operations. Fine, my dear students. So how much time it will take? Constant amount of time. Yes or no? Fine. Moving towards the next, suppose that if I just want to insert one more element, that is 1 now. So what I have to do? I have to perform again I have to do a comparison. After performing a comparison, we get to know that 40 is greater than 1, so we have to swap. Again we have to compare with the parent 1 and 20. Again we have to compare with the parent 1 and 10. So the final resultant tree is look like 1, 10, 30, 20, 40, 60, 70, 80, and here it will be 40, I think. So here is 50. So now if you see the comparison and swap are doing in this path, that is log n comparison, and we have to perform in the worst case log n swap. That's why log n plus log n equal to log n. Fine, my dear students. So overall time is log n. Fine, my dear students. So in the insertion, in the best case it is constant time, in the worst case it is log n time, log n for comparison, log n for swap, asymptotically it is log n. So that is the case of insertion. If I move towards the deletion part, in deletion we just delete the root element, keep in mind, of any heap. Fine, if just I delete the element 10, if I just delete the element 10, what I have to do? I have to replace with 70. 10, now 20, and so if I have to perform the delete operations, so I have to just delete the root element, and what you have to do is you have to just replace with the last element, and the last element is 70, just go with that. Okay, so 70. After writing the 70 here, we know that now my heap is not in the min heap. That's why what I have to do, I have to just perform the heapify. And what is the task of heapify? Heapify task is to maintain the property of heap. Fine. So 70, 20 and 30, which one is the smaller element? Because I have to perform the min heap, 20. So 20 will be here, 70 will be here. Now 70 and 40 and 50, who is the smaller? 40. 40 is here, 70 is here. Fine. So in this case my resultant tree is 20, 40, 30, 70, 50 and 60. Fine, my dear students. So again, if I talk about the time complexity, what I have done, just delete element, replace by the last element, and then in this path I just follow the comparison and the swap. Fine, my dear students. So again, the heap of the height of I can say the almost complete binary tree is log n. That's why log n comparison, log n swap, constant time for delete, constant time for just replaced by the last element, overall log n. So always keep in mind, deletion time complexity is log n in best case, in worst case. Whereas if I talk about the time complexity of insertion, the best case is constant time, whereas the worst case is log n time. Fine. Next important part is build heap method. So my dear students, keep in mind you have to go with the algorithm that is build heap, which is very important. Why? Because if someone asks you, I have these list of elements and please create a heap, in that case we have two different methods. If you just go and insert one after the another element, then the creation of heap will take n log n time, whereas if you just follow this approach, that is build heap method, it will take order of n time. So always you have to mention the optimal answer, that is order of n. Fine, my dear students. So order of n is the right answer. How it behave, what is the working of that, you can just follow the Corman book, where they just give a mathematical expression to prove that it is order of n time complexity. So create a heap take order of n time. Now moving towards the next part, that is, suppose I have the heap, so how I can sort the heap, that is very important. The task is heap sort. See my dear students, suppose I have the min heap. Fine. So if I represent this heap into a tree, that is level by level, so in that case, see, this is the array representation of my tree. Now what I have to do, this is min heap and I have to sort this min heap. So what I have to do, just delete element. So as we know, after deleting the element, I have to replace by 40. So I can just write 40 here. So because I just delete 10, now the array look like this: 40, 30, 20, 70, 50, 60, and here I have 10. I am just storing 10 here, keep in mind, after deleting, because this I have the space at this position, so I just insert element 10 here. Now listen carefully. Again I have to apply the heapify because the root node violating the property of heap. So on that particular node we have to apply the heapify again, because I just want to consider the min heap. 30 and 20, which one is minimum? 20. So 20 is here, 40 is here. Now okay, now 40 and 60, 40 is there, so maximum it can traverse this path only. Find my, and the height of this path is log n. That means I have to perform log n comparison, log n swap. So the resultant trees look like 20, 30, 40, 70, 50 and 60. 10 is already deleted. Fine, my dear students. In this way, if you delete all the elements, one deletion take log n time. You have to delete all the element, it will take n log n time. So that is the complexity of sorting the heap, which will take n log n time. Fine, my dear students. So that is all about heap data structure, or I can say heap sort, where first of all you know what the meaning of heap, different type of heap, insertion, deletion, and I can say heapify method, build heap method, and heap sort, the complexity of heap sort. So we already cover the important sorting or the different sorting technique, that is insertion, selection, bubble, merge, queue and heap. Okay, my dear students, so you have to be aware with all the time complexities, best case, worst case, different operations time complexity, and what is the property of that. And now we are going to move on the topic, that is stable and in place technique regarding these sorting technique. Now after completing the basics or the important sorting technique, now we are moving towards the searching technique. So my dear students, the first problem, as we know the basic searching technique in our syllabus are two, that is linear search and binary search. Moving towards the first problem, that is how does a linear search algorithm work. Linear search, it means we can also call it as a sequential search. Fine, my dear students. Now see, in a linear search we start from the beginning of an array and compare each element with the target element which we want to search. Until you find a match, we have to perform these operations or reach the end of the array. Fine. It means what we have to do in the linear search, the task is we have an input array and we want to search a particular target element or element in that particular array. So what happened, my dear students? How we can perform the searching? In the linear search, as the name suggests, it is a sequential search in which we just take the first element, start from the array first element, and just take the target element, start from the array first element and perform the comparisons. If our required element, that is the target element, is equivalent to the array's element, then we return. Else if all the elements we just compare and get to know that that particular element not exist in our input array, then we can say element not found or element not exist. So the simple thing is how linear search work. It start working, it's a sequential search where we can search our element or the target element in sequential manner, one after the another of the element. What is the best case time complexity? When we can say the best case is the best case of linear search. Suppose that I have an array may be sorted, unsorted. I want to search something. The given element or the target element is just at the first element of the array. So what I have to do? I have to perform only one comparison. That is, I just take the target element, start with the array first element comparison. We have to perform the comparison, and we know that if the target element is equivalent to array's first element, then in that case we just perform only one comparison, or I can say it will take constant amount of time. So you see the answer here. The best case time complexity of linear search is order of 1 when the target element is found at the very beginning of the array. Moving towards the worst case, what happened in the worst case? From the array's first element we have to perform the comparison till the end of the array. That means there may be two chances. either my required element present at the end of the array or the required element is not present in the array. But still, in both the cases, I have to perform my searching, I have to perform my comparison in sequential manner. That's why in the worst case, if input array has n element, then I have to perform n comparisons. That's why it will take order of n time. Now the next important problem is when a linear search is suitable choice for searching in a data structure. So you can see that linear search is suitable for small data set. Why? Because if number of elements are more, in the worst case to search a particular element, it will take order of n time. That's why if my data elements or input elements are small, or the number of input is small, then I just go with the linear search. Moving towards the binary search. So the first problem is, what is the time complexity of binary search? In the best case, constant time. In the worst case, log n time. But instead of just going with the binary search, what we have to do is, like, instead of going with the linear search, what we have to do in the case of binary search, instead of going sequentially by just doing the comparison, my target is to reduce the number of comparisons. Because if I just perform n comparisons to search only single element, then my ultimate task is how I can reduce these number of comparisons so that overall time complexity will be reduced. So in this case, I just follow binary search. But the important point or the main constraints regarding the binary search is, you want to apply binary search, you have to apply the binary search on an input sorted only. If your input is not sorted, then first you have to perform a sorting and then you have to go with the searching. So my dear students, as everybody you knows that what the binary search is, it instead of just going with the linear search, it just find out the middle element of the array, then just perform a comparison, that is with the target element and with the middle element. If that is your element, then you just return, else you have to perform one comparison, that is you have to check the target element is greater than the middle element or the target element is less than the middle element. Suppose that the target element is greater than the middle element, it means your required element will always be in right subarray. Why so? Because the input is sorted. But if the target element is less than the middle element, then if that element is present in your input, then it always be present in the left subarray. So in this way, again you have to perform on the right subarray binary search or on the right hand side subarray, again you have to apply the binary search. But always you have to go with one side, either on the left subarray or either on the right subarray. You cannot perform searching on the both side. That's why the recurrence is T of n equal to T of n by 2 plus C, because initially I have n element. By just finding the middle element, I divide my array into almost two half, each of size n by 2. Then I can say either I can go left subarray or right subarray. That's why my recurrence is not 2Tn by 2, but it is T of n equal to T of n by 2 plus C for performing a comparison. Every time we have to perform the comparisons. Fine, my dear students. So in the final conclusion, I can say the linear search time complexity in best case constant, worst case order of n, whereas in the case of binary search, best case time complexity constant, but worst case is order of log n. But the point is, we just apply the binary search on a sorted input only. If it is not, then first perform this sorting. Fine, my dear students. So in this way, I can say these are the some of the important problems for your interview, where they may ask the question related to searching and sorting, working of searching, working of each and every algorithm, best case time complexity, worst case time complexity. And now I just move on the next topic, that is which sorting technique are stable, which are not, which are in place, which are not in place, and what is the meaning of stable and in place technique. Fine, my dear students. So my dear students, next topic is, like we already covered searching, sorting, different type of searching, their working, their best and worst case time complexity, and when to use which one. Fine. Now if I talk about two main terminologies, that is, one is stable technique and one is in place technique. So these two terminology again very important for interview point of view. Moving towards the first thing, that is, what do you mean by in place sorting? What do you mean by in place sorting? So you can see here, an in place sorting algorithm is one that sort the elements without using the important word additional memory proportional to the input size, or you can say just by without using the word, important word is additional memory, keep in mind. Fine. So when we can say a technique is in place technique, a technique is called in place when it will not take any extra space. Like if I talk about the dynamic programming concept, so in that case, if I want to find out the Fibonacci of n, so in Fibonacci of n, finding the Fibonacci of n take 2 की power n, that is exponential time complexity. But if I go with the I can say the dynamic programming concept, then it will take order of n time. Why? Because we just take extra space, an array of size which is equivalent to distinct number of Fibonacci calls. So my dear students, as you know that if I talk about merge sort, what the task of merge procedure is? It just take two sorted input and sort them into a new array. Fine. That means merge sort take some extra space, whereas in case of quick sort it will not take any extra space. Sorting is done in the same array, I can say in the same input array. So my dear students, that is very important, because again we are mainly bothered about the two things, that is, one is time complexity and one is space complexity. So talking about the in place technique, a technique which will not take any additional space, you can call it as that technique is in place technique. It means the algorithm rearranges the element within the existing data structure. We are not using some other data structure or a same, I can say, like if the input is in one array, so I am not taking extra array. Fine, I just perform my operations in the same array, even though you can just take the temporary variables, but that should be constant in nature without the need of auxiliary data structure like additional array. In place sorting technique is memory efficient because we are not taking any extra space, and useful when you have limited memory available for sorting. Again, that is very important, when to use in place, why there is a requirement. So when we have the limited space, then we can go with in place sorting technique. So my dear students, always keep in mind what the meaning of in place technique is. A technique which will not take any extra space or any additional space. So just talking about the examples of some sorting technique, so fine, I think I have to mention one. Okay, here I am not writing the definition of stable sorting, but keep in mind, my dear students, now I just tell you what do you mean by stable sorting. See my dear students, listen carefully the meaning of stable sorting. See, suppose that we have the input, that is 10, 5, then 10 and then 4, and I want to sort this input. So my dear students, you may say that, sir, these two 10 are identical elements or the same element. So to distinguish these elements, I can say this is my 10A, that is first 10, this is 10B. So after performing the sorting, I will get an output like this. that is 4, 5, 10A first, and then I'll take 10B. In the similar manner, I'll get 4, 5, 10B and then 10A. But if I talk about the input, in my input, the sequence of identical element is first 10A and then 10B. But in case of output, this identical element, this is equivalent to only this sequence for the identical elements only I am just talking about. But here the identical element sequences are changed with respect to input. So I can say this one is stable, but this one is not stable technique. Fine, this one is not stable technique. So my dear students, now moving towards the stability part. So what do you mean by stable technique? Stable technique means before sorting and after sorting, the ordering of identical element should be same. So that is the meaning of stable sorting. In place, not take any extra space. Stable, identical element, ordering before sorting, after sorting are same. Fine, means identical elements not change their sequences. That is the meaning of stable technique. So moving towards some examples of stable sorting. Insertion sort is stable, means if identical elements are same, then we are not change their position. Merge sort are stable and bubble sort are stable. But if I talk about merge sort, it is not in place. Fine. In the similar manner, if I talk about the example of, I can say in place technique, selection sort is in place, means they are not taking any extra space. Quick sort is in place, heap sort is in place, they are not taking any extra space. So keep in mind, you can give some examples like in this way, and other than that we have many sorting algorithms. So if you Google out which are the different sorting technique are stable or not stable, or which of them are in place or not in place, that is your task. You just go Google out all the major sorting technique, find out they are stable or not. So again, this is very important problem regarding the in place and the stable sorting technique. Fine, moving towards the next problem. So now as we already started the algorithm, but if someone if you ask, then my favorite subject is algorithm, then the first problem you may face is define the term algorithm. Define the term algorithm. Again, even just with an experience, I can say that like many of the students even don't know the meaning of, or they are unable to define what the algorithm mean is. When someone asks you, please you can define the term algorithm, they are just stuck because they know but they don't know how to deliver the answer. So my dear students, talking about the definition of algorithm, and even I can say this definition I just take from the our standard Corman book. So you can follow just Corman book, you have to read the introduction part, what the meaning of algorithm is. So moving towards the part, an algorithm is any well defined computational procedure. It means it's a procedure which performs some computation, and it randomly not perform any computation. It is in well defined manner that takes some value or set of value as input and produce some value or set of values as output. So I can say the task of algorithm is, it is a sequence of computational steps that transform the input into the output. That is the task of an algorithm. Most of the students just say, sir, it is a step by step solution of a problem. That is the right one, but if you just go with the standard or formal one definition, I think this will create a great impact on the interviewer, and they get to know, yes, you are a bit aware with the algorithm, you are like, you just go with the introduction of to algorithm Corman book, so it will give a good impact on that. Now the second problem you may face is, please define the properties of an algorithm. Again, many of the students know the basics meaning, that is input is 0, effectiveness, or I can say definiteness. So they know the meaning of, they know these words, but they don't know actually what the meaning of effectiveness is, what the meaning of take 0 or more output, 1 or 0 or more input, 1 or more output, or I can say effectiveness or definiteness. They don't know the meaning of these terminology, even though just they read somewhere and they just try to deliver, but they don't know the internal meaning of all these words. So my dear students, whenever you go for an interview, at least you have to know that subject definition, even that subject related to computer network, database, OS, COA, whatever it may be, and you have to know the objective of that subject, and if there is some specific terminologies, then what is the characteristics, what is the properties of all these stuff. Moving towards the properties of an algorithm, see my dear students, the first property you can see here, input, and all again I can say these properties I just take from Sahani book. Again, it's a very good book, you can refer all those from all these properties from there. So 0 or more quantities are externally supplied. What do you mean by 0 input? An algorithm must have 0 or more quantities or more input. So even, but the point with the student is they are not included this term externally supplied, means we are from typing from the keyboard, that is we can say externally supplied. So always keep in mind, never just say 0 or more, an algorithm has 0 or more input. No, an algorithm has 0 or more input which are externally supplied. You have to mention like that. Moving towards the second property, that is output. It has at least one quantity is produced. It means it should produce at least one output. If your algorithm not producing any output, you can say that it is not even an algorithm. You cannot say that that it is an algorithm, because the ultimate goal of algorithm is to produce some output, to solve some problem. Fine. Now the third is definiteness. Each instruction is clear and unambiguous. What do you mean by that? It means, suppose you are writing 2 plus 3 star 4. That means, what is the output of 2 plus 3 star 4? I can say we have two output. One is 14 and one is 20. Because now if I just write this expression, it creates a problem for me. To reduce or to remove that problem or the confusion, I just follow a protocol, that why not you follow, or why not you first solve multiplications and then additions. In that case, it gives me the output as only 14 but not 20, because we are in the dilemma situation, so that we make our protocols, we follow our protocols, and we are trying to remove our confusion. In the similar manner, the concept of associativity came into the picture. If we have more number of multiplications in an expression, more number of division in an expression, which one we have to follow first? Either we can go with left to right, right to left, whatever the protocol we want to make, we have to perform, just do in that manner. And the main task is how we can remove our confusion. Right? That's why the concept of priority and associativity came into the picture. So my dear students, it should be unambiguous and it should be clear in nature. The fourth is finiteness. If we trace out the instruction of an algorithm, then for all cases the algorithm terminate after a finite number of steps, means it should be finite in nature, means it should terminate within finite amount of time, means its time complexity should be finite, because if it is finite, then only it can produce the output. The last one is effectiveness. Every instruction must be very basic, so that it can be carried out by the principle that a person use only pen and paper. So you have to write all the instruction in such a way that you can just write all those instructions with pen and paper. Writing means you can just solve all those instructions. It is not enough that each operation may be definite, as in criteria 3 it also must be feasible. Fine. So these are some of the important properties of an algorithm. So always keep in mind, you have to know the meaning of, I can say first meaning is define the term algorithm, and the second point is how you can define the properties of an algorithm. So simple properties are input, regarding the input, regarding the output, regarding the unambiguity, regarding the effectiveness, regarding the definiteness. So always keep in mind, these are some of the important properties of an algorithm. So algorithm must have to follow these properties. Define the term data structure and type of data structure. Now after just covering the major topic of algorithm, what the algorithm is, what is the property of an algorithm, different type of searching technique, different type of sorting technique, what do you mean by stable and what do you mean by in place technique, just move on the topic, that is define the term data structure and types of data structure. Now my dear students, whenever you can go and just say, yeah, my favorite subject is algorithm, there is a chance that they may ask the problem related to data structure also, because I can say that data structure, programming and algorithm just considered as a one subject. Fine. So always just consider this one as a one subject. So either you mention or not, they are just by default considered it as a one subject. So the problem statement is define the term data structure and type of data structure. So as we know that what is the main concept, main use of data structure? Storing the data, then retrieving the data, that is the main task related to data structure. Fine. Or manipulating the data. So definition of data structure is, a data structure is a way of organizing, how we can organize our data and storing data in a computer. And what is the purpose of that? So that it can be accessed and modified. The word efficiently is very important, because we are not bothered, we are just not stuck on one data structure, we have different type of data structure, when to use which data structure, only the objective is how we can efficiently manipulate all those stuff. That's why my dear students, a data structure is a way of organizing and storing data in a computer so that it can be accessed and modified efficiently. Next, data structure are designed to provide a specific way to represent and manipulate, important word, represent and manipulate data to perform the operations like insertion, deletion, retrieval of the info and searching. They play a crucial role in computer science and programming, as they are directly impact the efficiency of an algorithm and the performance of software. It's very like dependent upon what type of data structure we are going to use to solve a problem or to write a logic or to write an algorithm. That's why my dear students, what is the concept of data structure? The concept of data structure is, it is a way to organize and store the data. It has, why we are doing so? So that we can access and modify the data efficiently. Fine, my dear students. Now moving towards the next next problem you may face. So the types of data structure. We know that we have mainly two type of data structure, one who store the data linearly and one who not store the data linearly. That means linear data structure and non-linear data structure. Talking about linear data structure like array, linked list, tag and queue are the linear data structure. Now if I talking about non-linear data structure, they are tree, graph and hash table. These are some of the non-linear data structure. So the important term, what is data structure, what is algorithm, properties of an algorithm, what are the different type of data structure. So these four problems you may face as your first or the second problem or second question in your interview, if you say that yes, algorithm, data structure and programming are my one of the interested area. Fine, my dear students. So keep in mind, be good with the formal definitions. Always you have to mention the formal definitions, because if you just miss out one specific word, or maybe that word is very important to describe the definition of that particular word. So again, my suggestion is to always just follow the standard reference book and just give me or just give the formal definitions of these basic or the standard terminologies. Fine. Moving towards the next problem, that is, what is an array? So we know that array is a data structure which store the data continuously and which store the data which are homogeneous in nature, which are of the same type. As you know, the default case is whenever always frequently we just write int a of 5. It means we are trying to take or an array of size 5 element or 5, and the size of each element is of type int. If int take 4 byte, we have to go with 4 into 5, that is 20 byte. If int take 2 byte, then 2 into 5 10 byte. If int take 10 byte, 10 into 5 50 byte. And always keep in mind, many of times I just ask the problem, can you tell me the size of an int data type? Most, even 99% of the students just tell me, sir, that they are of 2 type or they are of 2 byte or of 4 byte. No, my dear student, that is completely wrong. You cannot do such type of blunder in your interview. Fine. So my dear students, they are machine dependent. The size of data type are totally dependent upon the machine. So please Google out this stuff. Moving towards what is an array. An array is a collection of items of the same data type. This word is very important. You may say homogeneous, it's just store the data which are homogeneous in nature, or you can say same data type stored in continuous memory location. So in this definition we have two important words. One is of the same data type of homogeneous nature, you can say, or the second one is the continuous memory locations. Moving towards, again, whenever you can go with the data structure part, you have to know, even I already told you, you have to know the real time applications of each and every data structure. I just give you some hint regarding the applications, real time applications of some of the data structure, but if I just left out something, then it's your task to go Google out what is the real time application. Instead just saying that simple array, and you can just take an example of array like we are standing in a queue is an array, we can fetch any element. No, you cannot say all these type of stuff. Okay, you have to, as a computer science student, you have to mention each and every application should be real world applications. Fine. Like if I talk about the application like in signal processing, so array are used in signal processing to represent a set of sample, or you can say a data that are collected over time. We are in signal processing, we are analyze the signals data, we just take the signals reading, so those readings are going to be stored in an array. This can be used in applications such as speech recognition, image processing and radar system. So you can say this is an application related to EC or electrical branch, but still we are going to use some data structure that is called array to store the data or store the sample readings. Moving towards the next application, in PCB, you know that in operating system we are using the concept of process control block. So operating system uses array to maintain information about the processes. In PCB we are going to store the status of process. What is the ID of process? What is the name of the process? What is the location of process? What is the status of process? We are going to store these parameters. So each process is represented by a PCB, and an array of PCB allow the OS to efficiently manage and switch between the processes. Again, one more application regarding page table. You know that in the concept of paging we are using the page table concept, which are going to store some information related to processes. So in virtual memory system, an array known as the page table is used to map virtual address to the physical address. That is the concept of page table. In page table we are going to use data structure as array. The next one is interrupt vector table. Again, it just store the concept or just store the information related to your interrupts. Array are used to maintain an interrupt vector table which maps interrupt number to a corresponding interrupt service routine. This table is crucial for handling hardware interrupt efficiently. The next one is multimedia applications like video and audio, where again we are using to store the pixels. Again we are going to use array. So these are some of the real practical applications of array. Again you have to Google out, and every time at least minimum you have to know 3 applications of an array: stack, queue, tree, graph, then I can say hash table or hashing. Fine, my dear students, you have to know. Moving towards some of the more applications like data mining. In data mining, array are used in data mining applications to represent large data set. Again, this allow for efficient data access and processing, which is important in real time applications. As you know that NumPy, in Python you can use the library as NumPy. Again, this is an array data structure. This is going to use only array data structure. Next, resource allocation table. As you know that in operating system we are going to use deadlock avoidance algorithm, right? Banker's algorithm you can say, where we know, I can say, the number of resource available, what is the maximum requirement, what is the current requirement. So to store these type of information, again we are going to use array, or I can say mainly the 2D array. Next, in robotics or in financial analysis. So these are some of the real time applications, my dear students. So even though by just seeing this PPT or this PDF you may face that, oh, these are some very simple problems. Fine, my dear students, but really believe me, my dear students, whenever I just ask the problems, this problem, can you define the term array with real time applications, even most of the students are unable to give me the answer. That's why, my dear students, you have to ready with these type of like standard real time applications with the formal definitions. If you just give them these type of things, then yes, it will give you a positive impact on your interview. Fine. So what is queue data structure? Again, tell me the 5 real time applications of queue data structure. So again, after array we can go on queue. So again, it is a linear data structure. We know that follows the property of first in first out. In a queue, elements are inserted at the rear, or I can say the insertion means NQ, and removed from the front, that means DQ. So it resembles a real world queue, such as people waiting in line, where the first person in line is the first to serve. So in this way you have to add on some extra statement to explain the terminologies. Fine, my dear students. Sometimes what I just feel that whenever I just put some questions related to like stack or queue, they just start giving me the example first. They want to try to explain me with the examples. No, my dear students, what you have to do, you have to mention first some statements, some formal statements related to the data structure, and with that you can end up with a real time example. Fine. So that is the proper way to give you answer in an interview. Now again, I just already told you that these are the important things. You have to know the real time applications of each and every data structure. So application of queue, first one is task scheduling in operating system. You know that in the state diagram we are using ready queue. Fine, my dear students. So everyone just aware with this point. Task scheduling in OS. Queue are widely used in OS to manage task scheduling. Processes or jobs in a queue are scheduled for execution in the order they were received, ensuring what is the use of that? To ensure fairness to the FIFO principle. Fine, my dear students, that is the first application. Moving toward the second application of Q data structure, again you know that in the spooler printer spooler problem, we are again using the print queue management. In printer management system, print jobs are placed in the queue. Whatever we just want to print, if we just give multiple commands, then they are going to store in the queue, and one after the another the printing is going to be done. The printer serves these print jobs one by one, ensuring that print jobs are processed in the order they were submitted. Moving towards the next application, in BFS applications, if you want to traverse the graph, in graph traversal we have two different techniques, one is BFS and one is DFS. In BFS, that is level by level traversing, we are going to use the concept of queue data structure to store their information, who is visited, who is going to be visited next. Fine. Queue are used in algorithm like BFS for graph traversal. BFS explore all the neighbors of the node before moving towards their neighbors, making it is useful for the task like finding the shortest path in a graph. So with this application, you are aware with you just want to say that, yeah, my dear, yes, interviewer, I am aware with BFS, I am aware with the data structure used in BFS, and I am also aware with the applications of BFS, which is going to be used the shortest path in the graph. So with simple giving you just a simple applications, you want to tell the interviewer that yes, you know the basics of all this stuff, and again this is a very important point. Now moving towards the next, order processing in e-commerce. In e-commerce system, customers' order are placed in a queue for processing. Orders are typically processed in the order they were received, ensuring fairness and timely order fulfillment. If you are not maintaining a queue data structure, suppose I just put an order on Amazon and you also just put on Amazon, but I just put that particular order 10 days ago, but the problem is, if we are not following the queue data structure, that it will create a problem and the order is not timely fulfilled. Next is in network data packet handling. Fine, my dear students. So these are some of the applications of queue data structure. Moving towards the next part, what is stack data structure, and again give me some 5 real-time application of stack. That again it is a linear data structure as we know, but it just follow the property of first in last out or last in first out. A stack is a linear data structure that follow the last in first out principle or first in last out principle. In a stack, elements are added or removed only from the top. That is very important. That is called push operation and pop operations. This means the last element added to the stack is the first one to the remove. Fine, my dear students, and I think you already know what is stack data structure, but some of the students don't know how to define the term data structure or the stack data structure. So this is the answer for you, my dear students. Talking about the applications of stack data structure, first one is function call management. We know that we have we have nested function calls, so we have to store the incoming address. After completing one function call, we have to return back to our home. So what the address should be, we have to execute the next instruction of the previous function. Fine. So that again this is going to be used by function call management. Stack are used to manage function calls in programming. When a function is called, its context and local variable are put into the call stack. When the function return, it pop out from the stack, allowing the program to resume its executions. Moving towards the second applications, expression to calculate the expressions value. We know that stack are employed in evaluating arithmetic expressions. Fine. Next, in backtracking problems, again we are going to use stack, and the concept is same: first in last out or last in first out. Again, these two applications are very important, that is browsing the history, performing the undo and redo operations. So my dear students, please go through these real-time applications, and if you want to add on, you can add on. You just Google out, and always just try to tell the 5 or the 3 real-time applications which practically or often you are going to use in your daily life. Again, my dear students, my suggestion is queue and stack data structure are very important. When to use which data structure, you have to know very clearly. So now our the next problem is, what is the difference between array and linked list? So again, it's a very important problem. You have to know the basic differences between two data structure. It may be stack queue, it may be array linked list, it may be tree and graph. Fine. So moving towards the first difference, that is related to how the memory is allocated in these two data structure. The first one is array. Array are continuous memory block, but in case of linked list, they are not the continuous. We are using the concept of reference to the next node. So you can see here, array are continuous block of memory where elements are stored next to each other. The size of an array is fixed when it's created, and it usually allocated in a single block. Whereas in the case of linked list, consists with the nodes where each node contain the data and a reference part which is going to refer the next node. Even though I am just talking about the simple linked list, it may even, because we know that the linked list we can create with the help of structure, and in structure whatever the structure we define for a node, that is only the definition. So I can say the memory for nodes can be allocated separately, and it doesn't need to be continuous. Fine, my dear students. So one is continuous, one may not be continuous. Next, size. Array have a fixed size at the time of creation, whereas to change the size of an array, you typically need to create a new array and copy the elements, so it is an overhead. Whereas in the case of linked list, they can grow or shrink dynamically by just adding or removing, which cost is constant. We know that if we are on a node which we want to delete, hardly it will take constant amount of time. But the point is, first we have to move on that particular node, which will take order of n times, so they are not limited by fixed size. The third difference is totally based upon insertion and deletion operations. So in array, what is the time complexity required? In the linked list, what is the time required to insert as well as in delete? Next, moving toward the access time. In array, we can randomly access the element, whereas in linked list, we cannot randomly access the element. We have to go linearly, or I can say sequentially. The next part is memory overhead. In array, there is no such memory overhead, but in the case of linked list, we are using extra memory, fine, for referencing the next point. But again, sometimes we have some overhead also related to, see, if array have a fixed size and may lead to a memory wastage. Yes, it may lead to a memory wastage if the allocated size is much larger than the number of elements. Suppose that I just create an array of 100 elements, but I am just storing 5 elements in that. In that case, you cannot just delete 95 memory bytes. Fine. So that is an overhead in the case of array also. But in the case of linked list, whenever we required, we just make a node and just perform the operations. So in linked list have a smaller memory overhead, as memory is allocated for nodes dynamically, and each node only contain data and reference part. Fine, my dear students. Next, data locality, you know that. So these an implementation part, array is straightforward to implement, whereas in the linked list we require some extra effort to manage the node structure reference between the nodes, because with the help of structure we are just going to create a node. So these are the main differences between array and linked list. So please go with these slides. Please, at least you have to know 4 to 5 major differences between linked list and array. Now, as we know that whenever we are trying to create a node, whenever we are trying to define the structure, first after defining the structure, we want to create a node, we want to create the memory, or we want to take the memory. So we are using mainly two concepts, that is the use of malloc and calloc, that is memory allocation, and that is continuous memory allocation. Calloc means continuous memory allocation, malloc means just memory allocation. Now, my dear students, it is very important problem that we have to mention the differences between malloc and calloc. So please Google out, you can just refer Gigs for Geeks also, where you can easily find out a detailed description related to what the malloc is, how we can just thus give the syntax of malloc, what is the use of malloc, what is the use of calloc, and even we have one more term, that is reallocate the memory. So please refer those some important good domains for those. Okay, fine. What is the difference between malloc and calloc? So malloc is a function that creates one block of memory of a fixed size. In the case of calloc, it is a function that assign, the important word is that assign a specified number of blocks of a memory to a single variable. The second point is malloc only take one argument, but it will take two arguments because it assigns a specified number of blocks which we have to mention. The third one, very important, malloc is faster than calloc, whereas calloc is slower. Next, malloc has high time efficiency, but it has low time efficiency. Next one is, it is used to indicate memory allocation, it is used to indicate continuous memory allocation. The syntax you can see here, how we can write the malloc and calloc. We use the typecasting concept, that is void star malloc size of that particular memory which we want. Whereas in the case of that syntax, in the calloc syntax, we have to pass two parameter. Fine. So that is the main concept. Now malloc does not initialize the memory to 0, but in the case of calloc, they are by default initialized with 0. Fine. Again, go with malloc does not add any extra memory overhead, that's why it is somewhat faster, but calloc add some extra memory overhead, that's why it is slower. So these are some of the major differences between malloc and calloc. So you have to go through this domain, this URL Gigs for Geeks, where you can easily find out the differences. Fine, my dear students, and the actual meaning of malloc and calloc, which is very important for interview. Now, what do you mean by free method? Whenever we are trying to delete a node, so we have a pointer pointing to that node. So in that case, we are trying to free that memory. So the meaning of free is what? What is free method? So here you can see, its free method is in C is used to dynamically deallocate. For allocation purpose, we are using malloc and calloc and even realloc, but for deleting, for deallocating, we are using the method free. The memory allocated using function malloc and calloc is not deallocated on their own. We have to use the method that is free. The next part is, what is the use of reallocate method? That is, again, as I already mentioned you, reallocate means reallocation of the memory. It is the method which is going to be used in C for dynamically change the memory allocation of a previously allocated memory. In other words, if the memory is previously allocated with the help of malloc or calloc is insufficient for us, so we are going to use reallocate for dynamically reallocate the memory. So reallocation of memory maintains the already present value and the new block value will be initialized with the default garbage value. So if we need some extra memory, we are going to use realloc function, and whatever the extra block we just take, those values are going to be as a garbage value. So you have to go with the term malloc, calloc, realloc and free. These are the four basic terminologies for functions. You have to go with that in that part of data structure. The next is what is hashing. We know that in data structure we are going to use hashing. We are going to use the concept of hash function, hash table, which is going to use for the searching purpose, so that the searching will take minimum amount of time. So here what the hashing is, it is a technique which is used in computer science and data structure to map data. Why we are going to use hashing? To map the data of arbitrary size to a fixed size value. Even you can refer the core main book also, where you can find out the definition. Why we are going to use this mapping? For efficient retrieval and storage. If we store our data efficiently, then there is a chance that we can retrieve the data efficiently also. That's why we are going to use a concept of mapping, which is going to be called as hashing. How we can use the concept of mapping? With the use of hash function. So it involves applying a hash function which are going to transform the input data into the hash code, or I can say the hash value, which is numerically representation of the data. Now if I talk about the purpose of hashing, it is widely used in the range of applications like data retrieval, which take less amount of time, data structures, cryptography. So here are the major concept of hashing. First we are going to use a hash function. So it is a mathematical algorithm. So what a hash function property must have? So you have to go with that part also. In Corman they just mention what type of hash function you have to follow. We have different type of hash function like modulo function, boundary folding method and multiplication method. We have many different type of hash functions. Again you have to go with the Corman book, where they already mentioned the different type of hash functions, and even the major application of hashing is in the field of cryptography or the network security. So my dear students, if you are bit interested in computer network, then you have to know the meaning of hashing. Now the next thing is hash table. A hash table is a data structure that uses hashing, very good, to store and retrieve data efficiently. It is a bucket, or we can say the slots, where we can store these data. Next concept is the in hashing we know that collision is there. If collision is there, we can remove this collision by the concept of first one is chaining, then is probing, different type of probing, linear probing, then I can say quadratic probing, and then I can say the standard one is double hashing. Fine. So in there they have, even I can say if I talk about linear probing, it suffer from primary cluster. If we go with the quadratic probing, it suffer from the secondary cluster problem. So my dear students, my suggestion to you is, please go with the Corman book, please find out or please read out what the meaning of I can say linear probing, quadratic probing, why we are going to use all these type of functions. Okay, what are the major objective of applying the hashing, what is the goal of the hash table, hash function, what type of hash function we have to use. Okay, so we are just randomly use the hash functions. the main objective is to it has to be uniformly distributed the keys. Okay, that is the main objective. So keep in mind, please, hardly it will take a matter of 2 hours. Just go with the concept of hashing from the core mat. You can easily find out the detailed things related to this one. Fine. The next important part I can say in hashing is the applications of hashing. So I can say the first one is in the data retrieval part, in cryptography part, in password making the creating the password, and again, or I can say storing the password, and then in the case of file integrity, in the case of load balancing. So these are some of the real-time applications of hashing. Again, you can Google out, find the more applications, but the applications should be realistic in nature. So that is all about the hashing. Now we are moving towards the part of tree data structure, as we already completed stack, queue, hashing, array, and some basics of, or I can say the differences of array. And if I talk about the tree, first of all, you have to know the definition of tree, what the tree data structure is. It is a non-linear data structure. Now, if I talk about the tree, as you know, we have different types of tree. One is simple binary tree, next is binary search tree, next is I can say AVL tree, B tree, B plus tree, red black tree. So these are some of the important trees, or I can say the concept of tree. So my dear students, my again simple suggestion to you is, please go with the basic terminologies of each and every type of tree. It may be binary tree, AVL tree, binary search tree. Balanced binary search tree means like AVL or red black or B plus tree. So please go with the basic definition of each and every tree, because sometimes students are unable to define the term tree. Fine. So then my next problem is, what are the different balanced binary tree, or even most appropriately I can say balanced binary search tree. So a balanced binary search tree is nothing but a binary tree, first of all, in which the height of left and right subtrees of any node differ by at most 1. Fine. That means we are trying to balance the height of left subtree and right subtree. Balanced binary tree are important in data structures and algorithm because they provide efficient operation of searching, insertion, and deletion. If my tree is balanced, it will take less time to perform the operations like insertion, deletion, or the next one is searching. But if the tree is not balanced, like simple, if we have binary tree, or if we have left skew or right skew binary search tree, in that case it will take more time to insert, to delete, to retrieve the things. Fine. That is the purpose of simply balanced binary tree. There are different type of balanced binary tree, and some of them are very like I can say important. First one is AVL tree. Fine. So it is a self-balancing, important term my dear students, it is a self-balancing binary search tree. In the AVL tree, the height difference between, again the same concept, left subtree and the right subtree is at most 1, or we can calculate it by finding the balance factor, where the balance factor means is height of left subtree minus height of right subtree. If we are not taking the modulus sign, then it should be minus 1, 1 or 0, but not more than 1, not less than minus 1. Now the second one is red black tree. It's again another type of self-balancing binary search tree. It again it is going to use the same concept, but with the help of coloring the nodes, and the main property it has to follow is no two adjacent nodes have the same color. So you can see here a red black tree is another type of self balancing binary search tree. It ensures that the tree remains balanced. My dear students, even I know that you know all these concepts, but the way you are delivering, that is somewhat important in the case of interview. So my dear students, try to read out all these notes and try to practice yourself in the front of mirror that how you are trying to deliver your answer. That is very important, my dear students. Red black tree maintain the balance by coloring each node with either red or black and applying the rule to ensure that no two red nodes are adjacent and the height difference is within the bound. That is the concept of red black tree. We have one more balanced tree, that is called B tree and B plus tree. We know that B and B plus tree are self-balancing again tree for using the purpose of indexing. You know that in database management system we are going to read B and B plus tree in the case of indexing. Fine. So what is the purpose of B and B plus tree? Creating the indexes. They have a variable number of child nodes per node, that is the important point, and maintain balance through the rules related to the number of keys, or I can say number of block pointer, number of keys, number of record pointer. If you are a bit comfortable with the DBMS B plus tree, that is the same one. So please go with the, I think for B and B plus tree, the best part is you can just follow the Navathi textbook for B and B plus tree to find out the internal concept, how much time it will take, what the level is, so and how many number of keys a node can store. So again, that is very important. Fine, my dear students. So if I just talk about the definition of binary tree, what a binary tree is? A tree is binary tree in which each node has at most two child. Moving towards the next concept, that is, what do you mean by binary search tree? First of all, keep in mind a binary search tree is simply a binary tree in which the parent node is always greater than equal to its left subtree, or you can say left child, and the parent node is always less than equal to its right subtree or the right child, you can say. Fine, my dear students, that is the concept of binary search tree. Now binary search tree may or may not be balanced. So in that case, if a binary search tree is balanced, or if it is not balanced, then we are putting some protocols or constraints, and that is called the AVL tree. Fine, my dear students. So in this way you have to know the operations, how to insert, how to delete, how to, I can say, yes, to search a particular element, how much time it will take, because I am not considering these points in this interview list, but you have to know. That's why please Google out the time required to insert, to delete, to search an particular element in in binary tree, in binary search tree, in AVL tree, red black tree, in B and B plus tree. It's your task. You have to find out, you have to learn the concept, what the time complexity is. So there is a chance that they may ask the question related to the definition part, related to the working part, or related to the time complexity part. So my dear students, please go with this part, okay. Now after covering all the problems related to the binary tree, binary search tree, different type of balanced binary search tree, we are moving on the topic as we first discussed the AVL tree. Now sometimes they may ask you, okay, we have a balanced binary search tree which is AVL. Can you just tell me the drawback of AVL? Because in most of the time students are not aware with the advantage disadvantage, or mainly I can say the drawback. So my dear students, be ready with all these type of problems. Now start with the AVL tree. We know that what the AVL is. It's a balanced binary search tree. It is not simply binary tree, it is a balanced binary search tree. Fine. So we know that AVL tree are a type of self-balancing binary search tree where the height of difference between the left and the right subtree of any node is at most 1, or I can say that is -1, 0 or 1. While AVL tree provide efficient searching, insertion and deletion. Why? Because the height of AVL tree is log n. So it maximum worst case it will take log n time for searching, log n time for deletion, and log n time for performing other operations or like insertion. Now moving towards the first drawback, that is it has highly overhead. In AVL tree we have a overhead, we have a specific overhead. See how AVL tree require additional memory to store the balance factor. Whenever you are trying to calculate the balance factor, you need to store, and every time you need to store, because whenever you are performing some rotations there may be a disturbance on other node also. That's why you need to store the balance factor for each node. Keep in mind, for each node. This additional overhead can make AVL tree less memory efficient as compared to simpler data structure like binary search tree, because in binary search tree we are not bothered about this other terminologies like balance factor, but in the case of AVL tree we have to store that value, and whenever the value goes beyond the limit, that is -1, 0, 1, then we have to perform some rotations. And again my dear students, I am saying rotation is again an overhead because we have to perform extra operations. That's why the second drawback is slower insertion and deletion operation. Maintaining balance in AVL tree through rotations and adjustment. We know that we have mainly 4 type of rotations. That is, if we have the problem of right, then we perform a rotation of left. When we have a I can say problem of left problem, then we can perform a right move or right rotation. If we have a problem of left and right, then first we convert this problem into left, that means we need to perform a right left or LL. So mainly we know that we have 4 different type of rotations, so accordingly we have to perform the rotations. So RL is there, first we can convert into RL, RR, and then convert just take a left move. In the similar way, if we have LR, then first convert into LL and then perform a right rotation. So my dear students, that's why I can say the slower insertion and deletion operations. And the thing is, whenever we are trying to insert any element or whenever we are trying to delete any element, in that case we have to keep in mind the balance factor, and if there is a disturbance in the balance factor, then we have to perform unnecessary rotations. Even though those I can't say those are unnecessary rotations, but we can say it is an overhead. Fine. So the next drawback is complex to implement. So AVL tree are very complex to implement. Why? Again, the overall things is revolving around the concept of rotations. So you can see here, implementing AVL tree correctly can be challenging, especially for those who are not familiar with the intricate rules and rotations operations which are required to maintain the balance, and this complexity can lead to implementing error. So if you are trying to implement a big AVL tree, and if somehow if you just face a error related to the balance factor, error related to the I can say the insertion or deletion operations, So you have to perform all those rotations. So if the tree is very big, so you have to follow the rotations. So it is a challenging or complex task, and every time whenever you are trying to insert or delete, the same thing you have to keep in mind, the balance factor. Moving towards the next drawback, that is frequent rotations required whenever you are trying to insert or delete. That's why it becomes slower. The next part is lack of flexibility. That means AVL tree are designed to maintain strict balance, right? Because the AVL are strict balance binary search tree, which may not always be necessary or optimal for certain applications. In some applications, a less strict balance requirement may lead to a better performance. It means sometimes we are not bothering about the balancing or the balancing concept, that the tree should be balanced in nature. Fine. In that case, there is no requirement of going with the AVL tree, because AVL tree are not that much flexible. Next, the most important part is the memory fragmentation. Frequent balancing operations, we have to perform LL, LR, RL, RR. We have to solve this problem. For that, we have to perform the rotations, can lead to a memory fragmentation in some implementations, which can affect the overall memory utilization. Fine, my dear students. So this is one of the important, I can say one of the important drawback of AVL tree. The next part is inefficiency of certain workload. That means in workload with the high number of insertion and deletions, other self-balancing data structure where we don't require that much rotations, like skip list or separate tree, these are the advanced concept, may be more efficient due to their simple balancing mechanism. So sometimes AVL tree are not good, even though we want the balancing structure, but still, because the more number of rotations required, that's why if more number of insertion and deletion are there, why we go with the AVL, why not we go with the other list like skip list or separate tree. So these are some of the important drawback of AVL tree. So you have to keep in mind all these stuff. At least you have to memorize 3 to 4 drawback of AVL tree. Now we are moving on the concept of drawback of binary search. We know that what the binary search is. It is a partially, I can say, divide and conquer technique, where we are not performing the combining part, but we are dividing, and we are dividing on the basis of the mid value. If I want to search something, I have to perform, I just find out the mid value, and then we have to perform the comparison, a comparison between target value which we want to search and the mid value. If both are equal, then I just return that particular index or the value, but if not the case, then we have to perform one more comparison, that means which is used to check that there is a possibility of my target element may be present on the left subarray or on the right subarray. So that we just perform a comparison with the target element. If the target element is less than the middle value, then there is a chance that my element, if there, then present on the left subtree, otherwise it will not be there. Or if my target element is greater than the mid value, then in that case it may be, if present, then on the right subarray, else not. So that is the basic concept of binary search, and we know that the best case time complexity constant, worst case time complexity log n. So now everyone know the concept of binary search, but the problem they may ask you regarding the drawback of binary search. Even though we know that searching is a frequent operations, in I can say in most of the problems, if we want to go for a particular or optimized solutions, then we have to perform searching and sometimes sorting also. But the point is We have mainly two type of in our syllabus. We have some advanced searching also, but the mainly linear and binary search. And linear search is not that efficient than the binary search. That's why we are trying to always implement binary search, and mainly when the input is sorted. But my dear students, you have to keep in mind the drawback of binary search. So here you can see that binary search a very efficient searching algorithm mainly for the sorted list, but it can also have certain limitations, or you can say drawback. That first one is sorted data requirement, and in most of the time, I can say even 99% of the times, whenever I just ask this problem, please tell me the drawback of binary search, this one is the first drawback. That means it just applied on sorted data, means binary search require the input data to be sorted in ascending or descending order. You can say, even I can mention here only ascending, but you can go with ascending or descending. So just mention sorted order. If the data is unsorted or needs frequent update, the sorting operations can costly, because we require the sorted data, and if we just perform any updation, then accordingly we need to sort it again, which is a costly operation, and maintaining the sorted order can be a challenging task. So that means, if because we can just the constraint is we can apply the binary search on a sorted input, and if input is sorted, but afterwards if we want to insert, or afterwards we want to delete anything in that particular array, because we have to maintain the property of sorting of sorted input, that's why we have to first sort them. And if we frequently perform the updation, then frequently we go with the sorting, which is a costly operations. Going with the second important drawback of binary search, that means inefficient for dynamic data. That again just related to the first part, if the data is frequently updated, such as insertion, deletion, updation, so binary search may not be most efficient choice, because each update operation may require resorting the data, which can be time consuming. So that is overall I can say the same point. But in the first point I just discussed about the updation part. In the second point I am also included insertion and deletion. Now moving towards the third part, not suitable for linked list. Binary search, as we know that it is applied on the sorted I can say in sorted input if linked list is sorted, but the point is in linked list we cannot randomly go on the middle point or the middle element. In that case, again to find out the middle element we have to go with the linear sequence. But the overall task of binary search is to improve the performance of linear search, but in the case of linked list it cannot be applicable. That means binary search is primarily designed for array. It does not work efficiently with linked list because it relies on the random access. It's totally depend upon the random access, where in linked list random access is not possible. So always keep in mind, my dear students, these are some of the important drawback of binary search, and someone may ask you the problem related to these points. So please go with this document. The next part is limited to static data structure. Again the same case, if it is not the static data structure, then frequently updation, frequently insertion, frequently deletion is going to be there. Again we have to follow the sorted property, so that we have to maintain the property. For maintaining we apply the sorting algorithm. That is the overall conclusion. Means binary search is most effective with static or semi-static data structure. In dynamic data structure, where the data are changed frequently, other sorting technique which are totally based upon hash tables or tree based are more suitable. Moving towards the fifth drawback, no information about duplicate value. Again that is the most important. See my dear students, Duplicate values. Binary search identifies whether an element is present or not, but it does not provide information about the number of occurrences or the position of duplicate values. Here I want to give you an example. See my dear students, suppose we have an array which is sorted. So I think if input is sorted and if we want to search something, then always we go for binary search. But there is a condition on the input. Even though input is sorted, but suppose that I have 10 element. Out of 10 element, one element came 2 times and remaining are 8 distinct element. So I can say overall total number of distinct values are 9. Out of that, one value came 2 times and other 8 are unique. Like the input may be 10, 20, 30, 40, 50, 60, 70, 80 and then 90 and 90. So in this case, the objective or what I want is, I want the element which is repeated in nature, that is 90. So if I just apply the binary search on this input, I just go with the middle value. Middle value is the like I can say 50. So now after finding the middle element, so I don't have the target value. The target value, I don't have a particular key in my hand. If that is the case, then I can easily go with either left on the left subarray, on the right subarray. But what I can do, even the input is sorted and I want to perform the searching, but I don't have a particular key in that point. In that case, after finding the middle element, to whom you have to compare? If you find out the repeated element, what you have to do? You just compare 50 with the left child, 50 with the right child. As the left child of 50 is 40, it means 50 is not repeated yet. But if I just go with the right child of 50, suppose that is 60, it means 50 is the one who is not the repeated element. So how you can proceed? Now how you can decide that the repeated element may present on the left array or may present on the right array? There is no, you are unable to take a decision after finding the mid element that either you have to move on the left subarray on the right subarray. That is the problem with the binary search. For the I can say duplicate values, finding the duplicate values is a big challenging task, or even you cannot perform the binary search in that case. Fine my dear students. So that is the basic problems of, or I can say the drawback of binary search tree. So you have to go with the drawback of binary search tree. Again, it is a very frequent asked problem in the interview. Now moving towards the next part, that is, please tell me some applications of linked list. See my dear students, again I advise you, please go with the applications of each and every data structure. Here the problem is, what are the applications of linked list? Again, the first application is memory allocation. As we know that even in file structure in operating system, we use the concept of linked list, or we in the Unix structure also we follow the linked list. So that is the first one is the memory allocation in C and C++. So in low level programming language like C and C++, linked lists are commonly used for dynamic memory allocation. Fine. In linked list we are for dynamic memory, linked list is a for dynamic memory allocation we use the linked list. That's why it is a one of the applications of linked list. Memory is allocated and deallocated using the function malloc. We can allocate using the free, we can deallocate the memory. Linked list helps manage the free memory block efficiently, yes, and allow for dynamic allocation and deallocation of memory. That is the first application, means memory allocation. Second is in music and video playlist. We just, because each and everything are just going to be stored in the form of linked list, in the form of nodes, and our reference for the next pixel is going to be there. So linked lists are used to implement playlist in media players, right? Each node in the linked list represents a track. It means a node represents a track or a video, a frame we can say, and you can easily add, remove, traverse the playlist. Linked list enable you to create dynamic playlist, that is fine. So the first one is memory allocation, second one is in playlist, third one is again browsing the history. Even we are using browsing the history for array also, stack also, but linked list also. Web browsers are use linked list concept. Suppose that you are opening many tabs, so if you want to move on the on previous tab or any of the tab, there you can use the concept of linked list. So web browsing uses linked list to manage the browsing history. Each web pages visited is represented as a node. Keep in mind, because they may ask you how you can say that linked lists are going to be used in browsing the history. Fine. So keep in mind, each web page visited is represented as a node in the linked list. User can navigate forward and backward through their browsing history by traversing the list. So again, it's a very important application. As we know, next one is symbol table and task scheduling, whereas task scheduling in real time system. So if I talk about the symbol table in compiler uses symbol table to keep track of, yes, variable, functions and other symbol. Symbol may be token, symbol may be, we have different type of symbol. We know that in the compiler we just create a most of the phases are just connect with the symbol table, where we can store the category of the symbols. Fine. So here we are using the linked list. The last one is task scheduling in real time system. So in real time operating system, linked lists are used for managing the task and processes with different priorities. The linked list allow for efficient scheduling and reordering the task based on their priorities. Whenever the priority, the concept of priority is there, at that moment of time we are using the linked list in real time scenarios, in real time systems. So these are some of the important applications of linked list. Please Google out some more applications, and while interviewing for the in interview you have to keep in mind at least three applications of each and every data structure. And my dear students, even though you know the applications, but you have to practice in such a way that you are be fluent and you can easily tell them the applications of I can say each and every data structure. Fine. So you have to be perfect in that part. Now the next part, I just take the question from the programming. In C language, we know that we have some specific storage specifier. We have mainly 4 type of storage specifier, that is I can say static, auto, extern and one is register. So this is a chart, again I just take from the Geeks4Geeks URL. So you can refer that URL for more information regarding the different storage specifier and what is the use of that, what is the meaning of that. Fine. You can please refer that URL. That is very very good resources for learning. I can say many of the it's the again I can say important URL, a very beautiful URL where you can learn the maximum all that technologies. Fine. So my dear students, here the explain different type of storage specifier. We know that we have mainly 4 type of storage specifier. One is auto, one is extern, one is static and one is register. So what the storage we have? For auto we are using the stack memory concept. For extern we are using data memory. As we know, memory is divided into some parts: heap part, stack part, data part. That so in static, if I just mention a variable as static, it is going to be stored on the data part or data segment part, and if I mention a variable as a register, so it uses the storage of CPU. So you have to keep in mind auto, stack, extern, data, static, data, register is only register. So you have to learn only one thing, that is auto is always going to be stored in the stack part. Fine. External and static by default data, register is CPU. Now moving towards the second thing, that what the initial value. Whenever I say static int a, whenever I say auto int a, extern int a, register int a, what their value or what their default value is. If I talk about the auto, it just take a garbage value. Talk about the extern, 0, initialize with the 0, static variable initialize with 0, register again garbage. So in the case of auto and register, they just take the garbage value. In the case of extern and static, they just initialize with value 0. What the scope of these variables? Whenever I just make a variable as auto, extern, static or register, what is the scope? Are they can be called from, or they just refer from any of, from every side, from every point of the program? See, so the scope of auto variable is within that particular block. If I just go out of the block, then I cannot take or I cannot go with the auto variable. The scope of extern is global, scope of static variable is again within the block, for register again within the block. It means out of 4, 3 have within the block, but extern don't have, because extern means external. Fine. Now the lifetime, what is the lifetime of these specifiers? So if I talk about the auto, it is, if it is within the block, if we can go out of the block, then we cannot access it. If I talk about the extern, it is till end of the program, because it is external variable, we are considering it is an external variable. Static till end of the program, register end of the program. So out of 4, 3 have end of the 2 have end of the program, but 2 have end of the block. It means register and auto are end of the block. Fine. Whenever their block are ended, then we cannot access these variables. Fine. So this is again a very important topic. Sometimes they may ask you different type of specifier, so you can go with that. And again, some of the important problems related to C programming I just mentioned you here, because like if you just mention that yeah, you love the programming C, so the first problem may ask like who make this language C. Then second is, in C we are using some keyword. Fine. So the point is, how many number of keyword the C language have? Even though these are the simple problems, but at least you have to count, or you have to Google out the total number of keywords. They may give you like some problems, maybe is 4 is a keyword, is switch is a keyword, continue is a keyword, break is a keyword, exit is a keyword or not. So these maybe they ask you the problem related to these also. So please keep in mind, my dear students, if you say that yes, C language is a preferable language for you, in C language you have to go with the from the basics to the advanced, means you have to know the file handling concept also. Fine, my dear students, you have to know the differences between structure and enum. You have to know difference between structure and union, what the enum is. So, and you have to know the concept of pointer, different type of pointer, pointer to an array, array to an pointer, all these concepts, how you can declare all this stuff. Fine. So these are most important topics in with respect to C language. So you have to be ready with that part. Now I am just talking about, as the concept of memory is going on. So the next problem is, what is memory leak? If I talk about memory, the concept of memory leak, see, you can read out first so that you can easily understand the concept of leak in the memory or memory leak. When programmer build memory in a heap and they are ignoring or neglect to remove it, so memory leak happen. The memory leak has the effect of decreasing the computer performance by lowering the quantity of memory that is available. It means you just take the memory from the heap section of the memory. After just using that memory, you are just, I can say, you are just skipping the removing part of that part. So at that moment of time, for the next process, the overall memory I need is somewhat less, or I can say in my hand now less memory is there. That's why it affect the overall performance and by lowering the quantity of memory. Always keep in mind it is talking about the heap section of the memory. The next part is again an important part of programming language. What is the difference between the statement break and continue? Sometimes we write the concept of break and continue and switch. My dear students, again keep in mind the concept of switch, because in switch we are writing the case, then we are writing the default. What happen if we just write the default at the topmost side? Is the remaining or the following cases are going to be executed or not? So you have to keep in mind, you have to refer all those detailed points. Fine. So the point is difference between break and continue. You can see here the break statement terminate the loop and bring the program control out of the loop, whereas in the continue, because break is used to stop the loop. Fine. If I talk about the continue statement terminate only the current iteration. Its task is to again to terminate something and to continue something. Always keep in mind. So the continue statement terminates only the current iteration and continues within the next iteration. Fine. Moving towards the next simple syntax, and the break can also be used in switch case, continue can only be used in loop. So again these are just taken from, I think, from the Geeks for Geeks URL, so you can refer that. Moving towards the next concept, pointer. We know the pointer, what the pointer is. If not, please Google out how you can define the terminology of pointer. Now we have different types of pointer. Talking about the first, null pointer. Null pointer are those pointers that do not point to any memory locations. It means you just declare a variable as a pointer, but you are not assigning any memory to them. So that's why a null pointer can those pointers that do not point to any memory locations. They can be created. How they can create? By assigning a null value to a pointer. You can see here what the pointer is, to whom it is pointing. We have to write the data type, but we have to initialize with null, so then it can behave as a null pointer. A pointer of any type can be assigned the null, that is fine. Moving towards the next concept, that is void pointer. Again, the void pointer in C are the pointer of type void. Even we have any type of pointer, but now here the case is type of pointer is void, then it is a case of void pointer. It means that they do not have any specific data type associated with them. Fine. They are also called generic pointer, as they can be point to any type and can be typecasted to any of the type. You can see here the syntax, that is pointer name with void. Fine. Next is dangling pointer. So dangling pointer, null pointer and void pointer, these are the three most important pointers. Dangling pointer is a pointer pointing to a memory location that has been deleted. In the linked list, we just free the space. Whenever we just, if we want to delete anything, in delete any node, then we just delete that node, and after that we have to free up that space. Fine, my dear students. If we not free up, then we can face the problem of dangling pointer. So you can see here a pointer pointing to a memory location that has been deleted is called dangling pointer. So these are some of the important points related to the concept of pointer. So different pointers like dangling pointer, null pointer, void pointer, then the concept of break and continue, then the concept of memory leak, and then the concept of storage specifier. So these are some of the important concepts related to C programming. They may ask you these type of problems also. So one of the problem again, like in pointers, what type of arithmetic operations we can perform. Suppose we have two pointers. So what different operations we can perform? Can we add two pointer? Can we subtract two pointer? Can we multiply two pointer? Can we divide two pointer? Please Google out all these questions also. So these are some of the problems related to C, and the next part. So my dear students, next as we already discussed the question related to stack, question related to queue, question related to array, question related to C programming, question related to I can say algorithm. In algorithm we already discussed about the searching technique, the sorting technique, in place technique, stable technique. Fine. Now we have one more topic in algorithm as well as you can say in data structure, that is the graph theory. So in this now we are going to discuss the questions related to graph theory. So if we moving towards the graph theory problem, what is a graph in a graph theory? So first of all, as I already mentioned you have to know the basic terminologies or the definitions of, I can say, tree, then the graph, then stack, queue, linked list, and all this stuff. So my dear students, how you can define a graph? As we know that in a graph we have mainly two components. I can say one is vertices or you can say node, and one is edge. Now you have to find many different applications of graph, but as you know, actually if I just go with the mathematical concept or mathematical definition, what the graph is nothing but it's a function from vertex cross vertex to a edge. Fine. So it provides a mapping, but here you can see a graph is a mathematical structure that consists of a set of vertices and set of edges. Okay, but you don't have to stop here, you have to mention that link a pair of vertices. Point means it provide you the mapping. Fine, my dear students, the meaning of this point that links pair of vertices means it's provide a mapping, associativity from the vertex to the edges. Fine, my dear students. So how you can define a graph? Even though you can also Google out, or even googling out, you can just go with the standard reference book, and from where you can just go with the definition of a graph. So I can say a graph is a mathematical structure that consists of set of vertices and set of edges that provides a link between the pair of vertices. Now moving towards the graph, in graph theory we have different types of graph, maybe directed, maybe undirected, maybe weighted, maybe non-weighted, or simple, or I can say where the complex or the loop is exist. So here the next problem is, what are the difference between a directed and a undirected graph? See my dear students, the simple difference is, in a directed graph we have a direction from which vertex to which vertex we are going. Fine. And in undirected graph there is no associativity like the related to directions. So you can say in a directed graph edges have a direction, meaning they go from one vertex to another vertex, but in an undirected graph edges have no direction and simply represent a connection between two vertices. It means in undirected graph there is no direction, whereas in directed graph there is a direction. That means from one particular vertex to another particular vertex we can reach out. Fine. Moving towards the next problem, that is explain the concept of weighted graph. Very simple. In a weighted graph each edge has some weight. We can represent, we can also say it as a cost. Fine. It means if you want to move from vertex 1 to vertex 2, what cost you have to pay, that is the meaning of weight. So in a weighted graph each edge has an associated numerical value that we can call it as a weight, such as it may be a cost, it may be a time, or it may be a distance. Suppose that if we mention 1 to 2 is 10, it means it may be 10 kilometer, it may be 10 meter, it may be you have to pay 10 rupees. That is the significance of that cost. According to it's totally depend upon your applications. What is a simple graph and what distinguishes it from other type of graph? My dear students, keep in mind we have different type of graph: simple graph, multiple graph, loop graph, or all this stuff. But always keep in mind, if I talk about the simple graph, it means the two things should not be there. One thing, there should not be a self loop in my graph. In simple graph, self loop never be there. And the second point is, if I just want to go from vertex A to vertex B, I have only one edges from A to B. I cannot have directed multiple edges from one vertex to another vertex. Fine, my dear students, that is the simple concept. So you can see here, a simple graph is a undirected graph with no self loop. I am not talking about cycle, I am talking about self loop, and no multiple edges between the same pair of vertices. The important word is same pair, multiple edges, no self loop. These three are the important terminologies you have to add while defining the term simple graph. Next, give 5 real world application of graph. Again, as I already mentioned you have to know the applications of each and every data structure. Advantage of one data structure or another data structure, real time application, advantage, drawback, when to use which one. Talking about the 5 real applications of graph, as we know, graph has many applications, like in social networking, like in transportation network, recommended system, computer network, in dependency analysis. So these are some of the basic terminologies, but I suggest you that please go Google out where we have to use the graph. Fine, in which type of real world applications we are using the concept of graph. Now, what are the 2 common ways to represent a graph in computer science, and what are their advantages and disadvantages? Now, most of the students know what the meaning of graph is, but they don't know how to represent a graph. So my dear students, if you just follow the Corman book, from the Corman book you can get to know what the meaning of a graph is. So my dear students, if I talk about graph representation, I can represent the graph in 2 different ways. It may be adjacency matrix and it may be adjacency list. Talking about the different 2 ways, when to use which method. So my dear students, if suppose that if your graph is a dense graph, the meaning of dense graph is like each or the number of edges in your graph is too high or number of edges are more, then which way you have to use, and if number of edges or the connections, or I can say the links, are less, then which method you have to use. As you know, we represent the graph in 2 different ways. The one is adjacency list and the next one is adjacency matrix. So if I talk about the graph which is dense in nature, means more number of edges, more number of links are there, then it's better to go for adjacency matrix. But if you have a graph which is sparse in nature, mean less number of edges or links you have, in that case you have to use the method that is adjacency list. Fine, my dear students. So I recommend you, please Google out or please go with the Corman book. Hardly it's a matter of half an hour. You can please read out their stuff of graph, representation of graph, how much space they required to store the information. So moving towards the problem, what are the 2 common ways to represent a graph in computer science and what are their advantages and disadvantages? So my dear students, we have 2 common ways to represent One is adjacency matrix and another is adjacency list. The matrix is efficient for dense graph, means number of links are more, while the list is efficient for sparse graph where the number of links or the edges are less. Moving towards the next problem, explain the concept of incident matrix and its uses in the graph representation. Sometimes we also construct the incident matrix, means which edge is incident on which vertices. Fine. So we just write down the information later to this one. So you can see here a incident matrix represent a graph by showing which vertex are incident to each edge. Basically it is useful for specific algorithm and can be represented in both directed and undirected graph. Now the most important problem, how you can traverse a graph. Mainly we have two ways. One is breadth first search and another is depth first search. So you can traverse a graph with two ways. Here the problem is, what is depth first search and how does it work in graph traversal? How it works, how it traverses the graph. So you can see DFS, depth first search, is a graph traversal algorithm, right? Now how it can traverse a graph, that is very important, and that you have to know how to deliver the answer. That explore, the important point is as far as possible along each branch before backtracking. It means it goes till to the last point and then it move on the backward directions. It goes till the depth of the graph and then move backward. That is, in this way DFS traverse the graph. For that, because it has to save the information related to which I can say which node it already traversed and what are the child which are not till traverse. So it has to keep that information. That's why it has to use the data structure that is called stack, or it uses the concept of recursion. Moving towards the next similar problem, that is explain breadth first search and its approach to exploring a graph. So again, if we have one method to traverse the graph as far as possible with the longest depth, one more method is why not traverse the graph level by level. That's why if you want to go with traverse the graph level by level, means first one node adjacent, all the adjacent you need to cover, then again for their adjacent you need to traverse. It means first you traverse level 1 all the nodes, then level 2 all the nodes, then level 3 all the nodes. That means BFS explore a graph level by level, visiting all the neighbors. In DFS we are not visiting all the neighbors, but in the case of BFS we are visiting all the neighbors of a vertex. The important point is before moving to their neighbors. That's why it has to use the data structure called queue. Fine. So in this way you have to know how to deliver the answer of BFS and DFS. Now again we are using the concept of graph in finding the single source shortest path algorithm. Fine, that is the Dijkstra. So the important is, please describe the Dijkstra algorithm and its application in finding the shortest path. As we know that in the Dijkstra algorithm, working of Dijkstra algorithm, when to use Dijkstra, when not to use Dijkstra. So please go out, please learn how the, or I can say the working of Dijkstra algorithm. Mainly what it does is, it can just first of all initialize, it use a function called initialize single source. That means it just keep a track that first of all it assume that each and every node has a infinite distance. Then it just select one node, that is start of the node from where we have to start our journey, and then it perform the relax operations. and the good point is it just relax each edge only once. That's what, according to that, relax means finding the minimum weight or finding the minimum distance. So you can go and Google out or follow the Corman book to find out the meaning of relax operations. So you can see Dijkstra algorithm is a single source shortest path algorithm that finds the shortest path from a source vertex to all the remaining vertex in a non-negative weighted graph. Important point. Fine, my dear students, because if in a graph I have a negative weights and they makes a cycle, then it creates a problem. Fine, my dear students. Now, how you can detect cycle in a directed graph using DFS? So, if in my graph, if we just go through, or if we are able to find out a edge that is called a back edge, then we can say that yes, graph contains a loop, or I can say a cycle. So whenever we are trying to traverse the graph with DFS, depth first search, and we get to know that there is a back edge. Now we have mainly different type of edges. You can say back edge, you can say tree edges. For that again you have to follow the Corman book, where they already mention the definition of the back edge, the tree edge, and all different type of edges. So by seeing these are very simple definitions, but my dear students, they may ask you these simple terminologies in your interview. So again, a simple suggestion for you is please follow the Corman book, where you can find out the definition of all these types of edges. So if you encounter an edge to an already existing visited vertex, it indicates a cycle. That is the simple concept, default concept. Moving towards the next problem, that is what are topological sorting and when it is used in graph theory. As you know that topological sorting, it means it is another type of sorting, but it provides you a linear ordering of the priorities of task. Fine, or linear ordering of the vertices. If I just go with the graph, that means we have to perform this task first, then only we can perform the task. Mainly it provides the linear ordering, and we are going to use the topological sort only in acyclic graph, because if graph has the cycle, we cannot construct the priorities. That's why always keep in mind, topological sorting is an ordering, or I can say it's a linear ordering of the vertices of a directed acyclic graph. Again, linear ordering, the word linear ordering and directed acyclic graph are the important words. That represents the direction of the edges. It uses in scheduling, means giving the priorities, and dependency analysis, which task we have to perform first, we have then afterwards. Fine. So again, a very good algorithm of topological sorting, where we are using the concept of DFS. We just traverse the graph according to the DFS, finding the finishing time, and as a node finish, we just add on in our ordering. So you can just take the again the algorithm from the Corman book, where you can easily find out. It's a beautiful algorithm which try to tell us in a directed acyclic graph the priorities between the task. So again, it's a very important algorithm. Fine, please go with that, the topological sorting algorithm. Now if I talk about, till now we just cover BFS, DFS, and then some of the other problems, graph theory. Moving towards the next problem, that is give 5 real-time application of BFS, breadth first search. Give 5 real-time application of BFS. Simply BFS is a concept or a technique to traverse the graph. Now we have to tell what is the real application of BFS. Again, finding the shortest path, because in the navigation system you know that. Fine. So you can see here that breadth first search is commonly used to in navigation system to find the shortest path between two locations, specifically in applications like GPS navigation system. It helps the driver, the cyclist to determine the most efficient route to reach their destination by exploring nearby roads and intersection using BFS. Next is again network broadcasting. In computer network, see, this is a simple graph theory problem applications, it is a networking applications, it is a social media applications. So you have to use the real time applications. In computer network, BFS is used to broadcast information or data packet efficiently. It ensures that data is sent to all the nodes in a network while minimizing transmission delay. This is particularly important in applications like internet routers, where data needs to be distributed to multiple destinations. So, my dear students, I think in GATE already they may ask you the problem related to the shortest path, or in how we can find out the shortest path, and even we can find out the shortest path using BFS and DFS also. Fine. Here again in routing we just construct the routing table, and router's task is to just forward the packet to the nearest neighbor which is free, fine, or the channel. So again here we can say that in networking, in computer network also we are going to use the concept of BFS. The third one is social network analysis. That means network like Facebook, like Instagram, like LinkedIn, we are going to use the concept of BFS, because if we want to find out the links, suppose that who is the my friend's friend is my friend's friend is my friend or not. So you see that in LinkedIn we have things called second connection, third connection concept, so that we can use with the help of BFS. Like social network like Facebook and LinkedIn uses BFS for various tasks including friend suggestions, friend recommendations, and detecting mutual connections. BFS helps to identify users who are within a certain number of connections from one another, which facilitate friend suggestion and network analysis. The next is web crawling and search engine. Again you can read out from here how we can use the concept of BFS in web crawling and search engine. Web search engine such as Google uses BFS to crawl and index web pages from one page to another pages. The algorithm begins with the seed page and explore web pages linked from it, which pages are linked from which pages in it using a breadth first manner. This process ensures that a wide range of web pages is indexed efficiently. So that means they are using they are using the concept of indexing also. Next, in puzzle solving, we know that in puzzle solving we are going to use the BFS. Again in the same manner, what the application of DFS is. The first one is again finding the shortest path, finding again I can say finding the path, I can say even path finding concept, that you can see DFS is often used to solve the problems, maze problems, and finding path from a starting point to a goal. It explores a path as deeply as possible before backtracking, because this is the functionality of DFS, this is the way of DFS. First go in deep and then move on the back, then take a backtracking. Next one is detecting cycle in graph. This is the important application to find out the cycle in a graph. You can see DFS can be employed to detect cycle in a graph. It explores the graph, mark the vertex as visited while backtracking. If it is already visited and you just move on next one more time, it means there is a cycle. Next application is, as already we mentioned, finding the linear ordering, that is the topological sorting. Next is finding the connected component who are strongly connected. And the next one is in grammar and syntax analysis, we are going to use DFS for constructing the parse tree. Fine. So these are some of the applications of DFS. Now the important problem. So you are saying that BFS and DFS are the traversing algorithm of graph, and we have many applications, but what time it will take, how much time it will take to traverse a graph, that may be the next problem. So here you can see, because in a graph we have the nodes, we have the vertices, we have the edges, so we are going to traverse each and every node. That's why node we can represent by V, E we can represent by E. That's why it will take V plus E complexity. Same DFS also, it will take V plus E. Now the most important problem, again one of the most important problem, as what is the difference between Bellman-Ford and Dijkstra, or what is the advantage of Bellman-Ford over Dijkstra? Please just analyze or just think about that. See, sometimes what happens in my graph, if there is a negative weight cycle, then Dijkstra don't give me or unable to give me the right answer. The point is, if in a graph having the negative weight cycle, then shortest path is not possible. But still, because the property of Dijkstra is it always relax each as only once or at most once, that's why it has to give some answer, but that answer is not true, because if the graph has negative weight cycle, then it is not possible to find the shortest path. That's why, my dear students, or shortest path from one vertex to that particular vertex. Fine. That's why, my dear students, even it Dijkstra not inform me that, my dear, in the graph you have a negative weight cycle, that's why I can say shortest path is not possible. So please stop your algorithm. Even Dijkstra not inform me, but that task is done by Bellman-Ford, and what Bellman-Ford does is it just relax each edge n-1 time, and it then find out some values, and then what happen, to check graph contains the negative weight cycle or not, it relax each edge one more time, and if there is a difference between any of the values, if there is a change in any of the values, then it says that please stop your algorithm because there is a negative weight cycle. Fine. So it means it relax each edge many times, whereas the Dijkstra relax each edge at most one time. That is the basic difference, or you can read out from here. Now I'll provide you some of the important coding problems. Sometimes in interview they may ask you to write the abstract algorithm of all these simple problems, and even many of the students who are bit comfortable with defining the algorithms, or I can say they know the meaning of sorting, they know the meaning of searching, they know how the graph algorithm works, but sometimes as a student we are not practicing that much for the coding part, we are not focusing on the coding part. At that moment of time it creates a trouble. So my simple suggestion to you is, my dear students, please at least go with 50 to 60 coding problems. At least you have to know how to write their optimal algorithm. That is very important. Sometimes they may ask you to write a code for the Fibonacci series, write a code for palindrome number, to check a number is palindrome or not, to check a number is prime or not, and if you just write the worst algorithm, anyhow it will impact on your interview. Fine. So I'll provide you some common problem list. Here you can see that the first common problem is calculating the GCD, that is greatest common divisor. Second most important problem is they may ask you please find out the LCM of number. Third one is factorial problem. Fourth one is try to check a given number, a input number is prime or not. Next one is we have to generate the prime number. Next, Fibonacci sequence we have to generate. Next, we have to given a number and we have to find how to write an algorithm to find the sum of their digits. Next one, again I already mentioned, even palindrome is the important one. Next, finding the how to find the determine a number is Armstrong or not. Next, important, one of the important is prime factor. You have to find out the prime factor of a number. Again, this is very important. Next, creating the simple linked list, finding the length of the linked list, how to insert a node at the beginning, at the mid, at the last, how to delete a node, how to find a cycle in a linked list, how to find a particular node in a linked list, how to delete a value, how to reverse a linked list. It is important. This one is important, my dear. Reverse a linked list. Again, this one is again most important. Detecting a cycle in a linked list. These two are the important one. Then third one important is merge two sorted linked list. Again, this one is the important one. You have to mention the algorithm how you are going to merge two sorted linked list. Then how to reverse an array, finding the maximum minimum element in an array. Then how to sort an array, all the sorting techniques. Merge two sorted array, we have given two sorted array, we have to merge these two sorted arrays. As we know that this concept we are already mentioned in merge sort algorithm. Now we have to find the nth smallest element using the partition algorithm within just order of n time in best case and n square time in worst case. Then remove duplicates, how we can detect the duplicate and remove the duplicate, how much time it will take. Search for an element in an array, calculate the sum and product of the array elements. So these are some of the important list of questions. For that you have to be comfortable with the coding part also. So my dear students, I think in this algorithm data structure and programming interview module series, or I can say in marathon series, I try to cover the maximum part, but still you have to follow the core main book, or I can say core main book, that their standard formal definitions. You have to know the applications, you have to know advantage, disadvantage, applications, their syntax. So that is my suggestion. Okay, my dear students, that is the marathon. Here I just want to complete my marathon series and the marathon series of algorithm, data structure and programming. Still, if you have any doubt, you can just contact or write the comment in the comment section box. Please give your feedback. Is it beneficial for you or not? But with my experience, I can say that these are some of the important problems. You cannot skip these problems for your interview. So thank you my dear students. We already published some marathons related to TOC, related to DBMS, related to operating system and like this. So whenever you are going for an interview, you can follow these type of marathon series which help you to crack your interview. Thank you so much.